Okay, so yeah, let me just check that this is indeed going to work. Aha. Okay. So yeah, we'll start off with just an overview of some of the sort of core features of Ethereum, because it's quite important to know, and have like a fairly sort of detailed picture of how this stuff works, so that we can go into detail about what Quorum is, how it's different to Ethereum, and what the sort of specific advantages are for using it, like specifically in our context, because there are a number of advantages, particularly sort of over the fact that you can set your block times, that you have kind of choice about which consensus algorithms to run and whatever. But Penny will go.
We'll get into that once we get there.
Once we've got through the pet shop tutorial as well, which we're going to go through. So yeah, we're going to start on this.
Cool. So I think, can you hook up the projector and we can start with that? Do you want to go? Do you want to go through this?
No, you got it. Yeah. Okay. I back you to give a better overview.
So also just bear in mind that I've skimmed through this like yesterday for the first time. So everything might not flow exactly in the best possible sequence, but if something doesn't make sense, please, this is a small enough room, I think we can just informally ask, like raise your hand or just stop me. Cool. But you're going to do the picture tutorial, right? Yeah.
Yeah, please feel free to ask questions and stuff as we go through. Like, interactivity is key here. That's what blockchain is all about. Query your peers.
So when you say in our context, are you referring to the like base context?
The SAFBC, right? Particularly, yeah. I mean, some very brief background around that is that Quorum just does make it easier to run a lot of these things in an institutional context, and it sort of provides for a lot more stability and performance than like running your own version of Git. Yeah. But again, like
we'll get there. Yeah. We'll get there. Okay, so who of you have bought any cryptocurrency? Let's start with just a show of hands. Who's bought? Okay. Who has and who specifically has bought Ether? So more than just okay, great. And I'm gonna ask, how are you storing that Ether? What do you guys say? Cold wallet?
A little bit on MetaMask, most of it on Exodus.
Oh, okay. Jack. Okay.
PayPal.
Hopefully soon Ledger and
Oh, great. So,
Yeah, I'm also keen to get on it.
So the reason why I asked is just to gauge a little bit of what you guys have done and not. So some of the stuff might be very way too basic.
So just the guys who see that, so you're all on the same
My balance there is the $3 $1 using.
All right.
You can have it back.
So at least they fixed the jack. So you now have to put a pin before you can do the part. Previously you could just do the part. So
wow.
That is the issue.
Yeah.
That beats joking about. Okay, so maybe let's start at some point by saying Bitcoin was been around for a while. Ethereum started. Big change between Bitcoin and Ethereum is they moved from a UTXO based model, an unspent transaction output model, to a state based model, and that state based model gives us the ability to program logic into what happens between different addresses, and we have then consensus on the logic that gets executed and the data that's updated. Sorry, the Slack message. Maybe I was just mute now.
I don't know why it's... Anyway.
You didn't do an all or everyone or something?
No.
Yeah. Okay, cool. But the basics are the same between Bitcoin and Ethereum in terms of you have a block that comes after another block and they are chained together. Child points to parents, all of that stuff. So I don't think it makes sense to dive into those details. What we specifically today want to dive into is more the new things that Ethereum gives us. Okay. So this tutorial you can go and read. If something doesn't make sense, you can go and read it, or just stop me. It's at truffleframework.com. Tutorials Ethereum-overview. Okay, and then did you paste that into Slack?
No, I pasted the video link for
okay. So let me just paste that into.
And then send a ripple through the Slack verse.
So everyone just mute it. Quorum Quorum. If you're not invited, ask Andy to.
No, Alex, I just made it there.
Cool. So that is the. Okay. So you can see it introduces here a reason for using blockchain is to reduce counterparty risk. It goes through databases and their role in a typical software stack. Goes through mining, the hashing part of it. So another reason for using Quorum that we'll eventually get to is that you don't need to mine these blocks. They actually just get produced at a set rate, or only when there are new transactions if you're using raw. Okay, transferring Ether shows the whole network being in consensus when you do that. Okay, and this then introduces the concept of smart contracts, and then how they can enforce certain rules. This then talks about the different Ethereum networks, so maybe let's just pause there for a second. So another great thing that Truffle provides is the ability to switch between different networks, and hopefully we get to see that today. We'll have the pet shop stuff deployed to the test RPC, but a simple Truffle migrate and specifying another network will allow you to actually just migrate all of your contracts to a new network, which is quite nice. And you can have several of these networks with different names. And all you need to do is there's a .js file, and in that .js file you just specify the sort of the endpoints for the different networks. So hopefully we get around to playing with that maybe a little bit today as well. Okay.
And it's worth just, the test networks for what it's worth. Like Robston was sort of Morden was first the main one, and that got killed, and then Robston came along, and it's also been under a lot of pressure lately because there's none of the economic incentive that securitizes the main network applies to Robston. So it's got like exactly the same features, but Robston Ether is worth nothing, right? So people don't mind spending it to DOS the network. And we've had a number of issues with that. So there's another network called Rinkeby, which works slightly differently, and it's sort of got a bit more sort of protection. I'm not exactly sure what the protection is.
So they're using POA, proof of authority.
Oh, so it's also POA.
Yeah.
Okay, because Rinkeby and Quorum
so they're both
are both sort of proof of authority rather than proof of work. And so you sort of specify a list of nodes that are allowed to produce blocks essentially, and that means that you don't open yourself up to the same DOS attacks that happen in Morden and Robston. POA was actually dead, Vinay was saying this the other day, right? It was dead in Singapore. Because Quorum is one of the
train stations there,
I had no idea. So, just a nice little historical tip, that's it.
Proof of authority, so here we actually have, we have Quorum using proof of authority, and we have Rinkeby using a proof of authority. So those are different public test networks you can quite easily use Truffle to connect to. Okay, and then enterprise networks, it briefly mentions Quorum. So it's important to note that there's a bunch of stuff that the Quorum needed to change, and we'll dive into this later. But the fundamentals in terms of how your smart contract executes, the EVM is exactly the Ethereum virtual machine is exactly the same between the two. The one that runs in Geth is the one that's actually running Quorum. So there'll be no difference in how your smart contract executes. And all of the hardening that has happened in the public and in the test networks we get the benefit of in the private Quorum networks, in any of the private Quorum networks.
Just a question on that. At the moment, I lastly in sync, the goals for the two networks seem to be very different. So
the two networks or software?
Well, the Quorum and the Ethereum. So if they start diverging a lot,
so
what is the plan to keep?
I think I can try and then you can probably correct me. He knows more about this stuff. So you've heard of the Enterprise Ethereum Alliance. So the reason, and the Enterprise Ethereum Alliance have chosen Quorum as sort of as a standard, or as a first implementation. And the goal of the Ethereum Enterprise Ethereum Alliance is actually to keep these two in sync. And you would have seen like Quorum is pulling in Get 1.6. So we want these to keep as close as possible.
Yeah, for sure.
And for that reason, Quorum hasn't done anything to change EVM. There's been no changes in that regard. So code, like literally, Truffle's written a blog post about how to switch from using the public network to Truffle is literally one of these network configurations that I was spoken about earlier, and then you're on, vice versa on the one browser. And that'll be the nice part about us using SAFBC, which is meant for public bidding, and then actually switching to the private network later on. So that's the one thing. The other thing is, so the reason why Pete and I, we also like keen on actually doing stuff in the private space, even though we love the public space more. The internet doesn't consist of one network. It consists of multiple networks. And eventually the aim is to have all of these talking to each other, all of the little private networks. And in that way, I mean, the same thing. If you go to Singapore, the internet's awesome. Like, most internet here is not that awesome. Yet we're on the same, we can email each other, right? So you might have the same thing where certain private networks just aren't as good as other private networks, but they are connected in some fashion. So the goal of Quorum is absolutely to stay as close as possible to what's happening in the public space. Is that answer you?
Yeah. My concern is just at the moment it's utopia.
But there will be active.
There will be some divergence.
There will be active efforts to keep them as close as possible and compatible, at least at an AVM level. So another interesting story. There was a bank that developed quite a lot of cross-border things on Ethereum, stock standard Get Ethereum. So they use Get for it. And then when Quorum came around, they literally just changed the network, and everything was still working. Not a single line of code apart from the network configuration that we need to change. And the idea is to keep that. That is what we want. That is the difference between what we're doing here and some of the other technology that's out there.
And it's also worth remembering what Kenny says about you get all the benefits of the hardened public chain if you keep that, right? And so like guys like Chain and some of the more private implementations, while they have great tech, that it's not being tested in the wild, right? So it hasn't had some billions of dollars thrown at it and all the hackers in the world. And so from both ends, you have this incentive to try and stay kind of quite tightly governed.
And hopefully there'll be a symbiotic relationship where some of the stuff we learn in the private space actually gets incorporated into the public space.
It sounds almost like Applet, because you end up having a Applet, and the guy mentioned that at least from their side, and I would agree, the best, or at least the easiest smart contracts that you get, and I think that's probably the current advantage, is a smart contract behind it. And then so said that that's actually the ideal as far as smart contracting itself. There's not so much implementation. I feel like you guys are taking a single approach to having the smart contracts issues with mining and so forth.
Okay. Get a little bit more.
Yes. So the EA technical working group, one of their primary principles is that the two can't diverge. And in fact, they're working to converge them more. So there's some stuff which has been done like in the private space. So on the roadmap is to say how can we make that more convergent with the public, and then bring some of those features in. So currently, like there's 4 proof of for functions that are safe but expensive,
Yeah.
we don't need them. But and then we're going to bring in a few more pre-compiles. We'll test them in the private space and bring them in, and then that'll make actually the public and the private even closer. So towards the end of the next year, we'll start to see like some of the confidentiality stuff in the public Quorum space. We're actually going to work to make the private space more compatible instead of less compatible.
So the last time we did Quorum, we had to actually compile that special version of Git. So you're hoping never to have to do that, you just install Git
Yeah.
and then add the constellation on the side.
I don't know. The thing is, obviously the Git development team, they need to decide whether they want that option for as a client. If it is, then sure, you'll have that option. But in the public space, it's up to the client to decide what features we will have or not.
And
we weren't using a special version of Get. We were just it was if you have Get already installed on the machine, you just had to move. You had to change the path, right? Because Quorum was requiring a specific version of Get.
Yeah. So
Okay, I thought
Yeah, it wasn't changed then. It was just a specific version.
so on that, so Quorum currently uses Git 1.5, just using 1.6. Quorum's in the process of upgrading to 1.6 as well. So they're definitely making sure that
keep up. Yeah. So if you even if you were using an older version of Get, we just wanted to sort of keep that binary somewhere safe, so that you when you type Get in your command line, you actually hit the Quorum FI Get and not the normal Get 1.5 or 1.6 or 1.4, whatever you want. That's all we wanted to do with that. Sorry, I misunderstood your question.
Yeah, no, that's because that little step means that it isn't the same one, but there's lots of different versions of Git.
Yes.
More
Okay.
about the functional support of the API.
Okay, cool. And then there's a little bit of an intro about that. Do you wanna actually just quickly talk about this, since the pet shop fits into this?
So I mean, I think that's everybody here is probably aware that like it's sort of time to move away from the client-server model and like thinking about that as how we produce production apps and sort of interact with the world. The whole kind of point, and especially, I don't know if you saw like Joe Lubin was on International Business Times, I think, yesterday. They published an article talking about Ethereum, and sort of he's really big on this idea that Ethereum is not just about moving currency and even moving value around, which is sort of where I'm kind of coming into. But he's saying this is a whole new way to do the internet, essentially, right? And especially, I don't know if you guys watched any of that ENS workshop. There are some seriously interesting proposals about sort of marrying ENS and DNS and the kind of things that you can do when you sort of add cryptographic security to the current protocols and a decentralized network. So instead of client-server applications, what we really I sort of like to kind of divide it up into what's on-chain and then what's client-side. And I think just from a sort of conceptual overview of this stuff, I think that it's important to realize that currently, and I think for the foreseeable future, what we try to do is keep as little code as possible on-chain. So literally when I sit down to write a smart contract, the goal is to keep it below 50 lines. Which, I mean, it's not always possible, but that's at least the goal, right? So because you want to try and ensure that only the critical, really critical business logic is on the chain, and everything else that you can possibly do is done client-side. And
client-side, and then also hooking into some of the more persistent things like Swarm or IPFS. I think the Swarm and IPFS is mentioned as well. So if you want to store a music record or whatever, don't put that on chain. But also you can't keep it client-side. So now where do you keep it? Okay, let's use Swarm or IPFS to actually just keep those files.
Yeah, and it's an interesting question that's unanswered at the moment as to sort of which storage protocol will win out, if any. Right, a lot of people, I think, particularly in the consensus community, seem to think that it would be nicer to use Swarm because we only want to have one token to run our DApps. But IPFS and Filecoin is a really, really interesting and exciting thing, and the fact that Filecoin has this intrinsic sort of valuable proof of work, right? Is really, really interesting. But Truffle now hooks into Swarm directly. It's so like there are a number of other protocols associated with Ethereum which we haven't really spoken about. Like the one is Whisper, which is the sort of gossiping, dark messaging protocol that's called SHH. And then Swarm is now accessible. Any of the Swarm gateways are accessible through PZZ. Just as a right. But like it's super easy. I mean, we issue certificates for people who complete our training, and so what we do with those certificates is we'll sort of put them into IPFS, take the hash, and store the hash on chain, and that's sort of what we mean by don't go and store like your actual things on chain, but store the cryptographic link there too. And in fact, like I'm doing that very simply, and I'm paying a bit of a price in gas to do that, but there are actually cleverer ways about how you sort of break down your IPFS hash. You can store them very, very cheaply. I've got a nice Reddit link for you guys if you want.
How sure is IPFS is for recently like partners to research? How effective and sure is that? Is it long ago? Is it really all now?
So IPFS is relatively speaking, for the technologies that we're going to be working with today, IPFS is mature and working well. Swarm is still sort of getting there, I would say. I mean, IPFS did a whole mirror for Turkish Wikipedia because that got censored, and so like they mirrored the whole thing, right? And they're working with like a whole bunch of people doing all sorts of awesome projects. I mean, it's been going now for 2 or 3 years. It works. It can be a little bit slow. Especially like that we're used to normal internet speed, so like it can be a little bit frustrating from time to time, but it works well, and like the concept behind it, right? Like this sort of content addressed stuff rather than location addressed. It really makes a lot of sense. The example that John Bennett gives on this stuff, it's like saying. There's this really great book. You guys have to read it. It's on the second shelf of the third bookshelf in the Johannesburg Central Library on the second floor on the left as you turn it, right? So like that's location, that's URLs. That's how we use it now. Whereas using content address where it's sort of hashed together and you use this merkleized DAG, it's like saying, this is the title of the book. It's called Stealing Fire. Please read it. It's amazing. It'll change your life.
And then you can go to any publisher.
Exactly, right, and it's the same content, and you can be sure that it's the same content because we've got the hash, right? So it's a very simple shift, but an incredibly powerful one.
Cool. Okay, so let's see what's next. And that's it on this introduction at least. Okay, cool. Do you guys want to dive into getting Truffle up and running? So you can go to. So if you go to the normal, like just truffleframework.com, you can click on, actually first do this.
Do it on the picture. They have the starters there and then the carry on.
Okay.
So
on the tutorial page, not the first link, but the second link, the Ethereum Pet Shop one, you click on, and then everything is there. Yeah, here we go. Do you want to hook your computer?
I do. Right. So does we should have told. Does everybody have Truffle installed? So it's literally just npm I with a G flag, and then Truffle. If you have npm installed, I suppose.
What is the latest version of Truffle?
It's 3.9.2, I think.
Just on the there's 3.4.9, which I think is still
Dash G Truffle.
Oh, 3.4.6 maybe is one that I've got.
Yeah, I thought
I don't know if this is going to let me record, and
what I have is
yeah, that might be.
Because you're streaming.
Yeah.
Don't do that.
It won't, so.
okay, so I will then keep the and upload to.
Don't forget the world is watching you. So don't pick your nose.
I won't. But I'm doing a screen share now anyway, so that's we can take a look. I'm sorry, I didn't realize that's.
It's fine, bro. It's fine.
Yeah.
Okay, so this is the commands to install it. This one and this one. Okay, do you wanna? I can actually just like go for it here. So I have already unboxed it here.
Oh, you have already. No.
So I've just done a. I've just done the up until I unboxed it pretty much all. Nothing after that.
Cool. So yeah, if you just get Truffle, it should be a really easy install. They've been working hard on making that super easy.
The minimum load version is 6.9.
I think so. Yeah, 6. Yeah, LTS.
6+. Yeah.
So I've actually recently moved to 8, or just the latest always. And okay, but
I use NVM. You know,
yeah, that's even better.
yeah, it's honestly like managing versions and stuff. It's just not worth it.
Like RVM as well. I mean, one point you forget what NVM version you're on right now. It's just a nightmare.
Yeah.
You just try to use the latest.
Yeah.
You need to download the Truffle box to a specific directory.
No, we're actually gonna. There's a CLI command to do this. So don't worry about downloading that Truffle box. You can just literally it's Truffle unbox pets dash shop. Yeah. Yeah. So
I don't know if Truffle does it.
there's
I don't think you can box it.
sort of just while you guys are getting Truffle, let me just show you this pet shop tutorial is not the only like that. So this pet shop tutorial is not the only Truffle box that exists. If you come to trufflebox.github.io, you'll see that you get like a normal React box. You get one that comes sort of standard with Redux and an authentication route. And then you get one with Redux and UPort authentication.
Can you create new boxes and send it back to them or not?
Yes, as far as I understand, you can.
So that's
Yeah,
pretty cool.
yeah. So if you do, please do. So I mean, the status guys, we created one for them.
Oh,
It's the status React
Great
Truffle
stuff.
box. And this UPort one is quite nice. I've sort of played around with it a little bit. You know, the UPort team is currently undergoing like a big refactoring of all their contracts and whatever to try and get the gas costs down. And there's some interesting blog posts out about that if you want to read them. That's kind of out of scope for today.
If you just go to the, did you go to the
Are the
tutorial page?
coding standards pretty slick in these that you can actually use them for a base of a project, or is it really have like
Generally,
just
so I
throw
mean,
away?
it kind of depends, honestly.
You don't need to just
You know, I mean, the thing with like React in particular, it's incredibly powerful, and I really like using it. It's just that different people use it very, very differently. So like that React box, it'll kind of get you going, but to be entirely honest, like I wouldn't have structured the project the way that they have, if that makes sense. So like it gives you a good sense of where to start, I think. But you know, like I might just put together a little Truffle box with like a few roots at the top and that kind of stuff, because that actually, like, once you put your roots in and got the components and everything working, like that's an actual box rather than just sort of slapping everything into one file. Because that Truffle box React is literally just got like app.js. And there's no like actual components folder. There's no really sort of separation of concerns. So yeah, if once you've got Truffle, if you'll just make a new directory, you can call it whatever. I called mine ETH Pet Shop, but Pet Shop tutorial, whatever you want.
So if you're having problems with other global installs that use older versions, just update those. So like with Badu now, we just needed to update his Express to the later version. On this step, so if you're running Truffle Unbox Pet Shop and it gives you problems about older like Express versions and stuff, just update it. Hopefully that's.
And while we're waiting for a bit, so I mean I'm never one to sort of prescribe text editors, so please go ahead and use what you want. I use VS Code, and I really dig it. The thing that I dig most about is this integrated terminal. Again, like it's yeah. I know. It's people feel really strongly about integrated terminals, right? And like again,
You would say they feel strong.
I mean, just the thing about it is, like I said, the advantage of Truffle is that everything is in one place. Your contracts, your front-end code, the fact that you can deploy it. So, like, if you have an integrated terminal there as well, then it's literally like, okay, cool, I can deploy, I can migrate, I can test, I can do everything.
I do see your point.
Is anybody having issues
Is
getting this?
anyone stuck somewhere that I can come and help? Like view this interactive and flowing, right?
Yeah.
So there's no like there's an idea of what we would like to achieve today, but there's no like if we don't get this, then everyone loses half a mark or whatever. Okay, so please feel free to put up your hand or even just shout I'm stuck, whatever. Okay. Alright. So is everyone able to move on to the next bit? Cool.
So yeah, what we're really looking for here, the Truffle guys have updated. It used to be Truffle and Knit. It's now Truffle and Box and Pet-Shop will get you at least, like what they do for you in this box, which is pretty neat, is they give you all the front-end code that you want, and then we're going to go through ourselves and actually write the contracts and sort of discuss what it is we're actually doing. And you'll see that, I mean, like these contracts are very, very simple, but like it's worth understanding like exactly what's actually going on, because as it turns out, Solidity is crazily simple, but writing secure smart contracts is crazily difficult. So
Question. You can still Truffle in it, right? Like
you can. I'm not even. It depends which version you're using. I think the latest versions will just give you Truffle Init has been deprecated. Please use Truffle and Box.
Oh, is it?
Yeah.
So, for example, they actually state here, like Truffle Init there will create something with no example. Like, it used to give you that MetaPoint example.
Yeah.
I think this will actually just give you nothing. But at least in Truffle is started. Yeah. Okay. Or initialized. Not started.
For VS Code, Solidity or Solidity Extended?
Solidity, yeah, the Solidity extension. Which one is it? Yeah, Solidity 0.029, I think, is the latest. So I have Solidity in the material icon theme, because that's pretty neat.
Material?
Icon theme. So it makes it makes your directory structure look pretty.
Smart on camera.
Oh yeah, shit. I've got to remember that. Sorry. Hey. But you're not really. I'm doing a screen share at the moment. You're not actually.
I just wanted to see their reaction.
I hate being on camera. I have no idea how much. I hate it.
Partially why I wanted Andy to.
You know the feeling when you're at a conference and you ask a question, you see the camera swing, almost
Okay.
Okay, so if you've has everybody unboxed it? As you can see, once you unbox it, what you should sort of have there is a contracts folder, a migrations folder.
We just show them.
There we go. Okay, so you get these
Oh,
boxes.
I just see it's a little bit small on that screen. I'm actually just going to make it a little bit bigger. I know most people are following on their own machines, but sometimes it's useful to. Oh yeah, sorry, you can actually just do that. Sorry, it's. I think it's. Why is this not working?
Yeah, I thought it was Control Plus as well.
Control Shift Plus.
Yeah.
Because this is not a Mac. The plus and the equals are swapped around.
Wait, what is this?
Okay, so this is sort of what your directory structure should look like. Your contracts, obviously, like that speaks for itself. That's where you're going to be sticking our contracts. It's worth understanding exactly what this migrations folder is. So you'll see you have to.
Yeah. May I actually just quickly do this?
I could not see the Ince migrations there. So if you that's really weird.
Install a new version of Node.
And
the
a downgraded
NPM version is
NPM.
3, and the older one was 4.
That's very
NPM
strange.
version is 3.
What Node version?
No.
I did the LTS install of Node.js, and now it says when I do version, it says NPM 3.1.
LTS is 6, right? 6.9.
Yeah.
And, like, just go.
But it was still newer than the one I had on.
Okay.
Sure.
Oh goodness, what version are you on?
1.
What?
Yeah.
Zero.
0.4.
That's one thing that drove me crazy about AppLedger is they're on, I think 4.9.5 or something stupid for one of their modules. So like, you know, all the nice like directory scanning, all that stuff, none of that exists.
Goodness.
So what is the version you're on now?
6.11.
NPM version. Or
No,
Node version?
NPM it says 3.10.10. 3.10.10. Node version is 6.11.2. But previously it said Node version was 6.9.2 and the NPM version was 4.05.
I think most of us are on
But all the
Node
other
8.
Yeah.
I'll do the 18.
Yeah.
Alright.
But use NPM like you
I
said.
just like doing LTS.
Wait, Node version 8?
But I mean, 6 plus will be
It
fine
should-
for what we do.
The LTS should be good. I mean,
Yeah.
that's the long-term support version. So.
So essentially, it's worth understanding what's going on in this migrations folder. Generally speaking, we actually have 2 files here. I see that we're going to have to make our second one. So, like Truffle, you know, in order to manage you deploying to multiple networks and deploying perhaps multiple times as you fix the inevitable bugs that will creep into the Solidity, you have these 2 files, one initial migration and 2...
So you can see this just literally deploys, is it deploying, and then if you want to open migrations at Sol, you just show them what that looks like.
Cool. Yeah, so it's literally just like migrations.sol is a simple Solidity like contract that just tracks where you deploy your contracts to on each network and sort of pumps those into the JSON file that gets produced for your build.
So you can see here,
Something
Hey.
later.
How's it going?
Maybe they got
We
they
just,
used the other appointment.
no, we
That's
just-
it started it down.
just follow Andy and ask him. Just open the window. Yeah, so you'll see this migrations contract. So this is the Solidity contract, and it just keeps track of the owner, the last completed migration. Yeah, and then when you upgrade, you change you deploy a new version. That's all it really does. It's pretty simple, and this is then how you then deploy the contract. Sorry, I'm taking.
It's all good. No, because you're much better on your terminal than I.
See, but this is you were talking about integrating terminal into your development environment, right?
You can't really do this stuff. I completely. I understand. I get it. I suppose the other thing, sort of, just worth looking at in these particular things is, like just very, very quickly, you can see that you've got your SRC folder there. That's sort of where all the front-end code is sitting. That's given to you for free in this box. The tests, we're going to sort of get into those and actually write a test as well, because that's everybody in the room's favorite part of development. And then I like Nano.
That's fine. Use whatever you just start without the first one.
So this is sort of what the Truffle.js file looks like, and this is really like your network config file, right? So as you can see, we've only got one network listed in here at the moment, so this will be our default network. We're calling it developments, and you can see that it's set up for our local host, right? So this is if you're running test RPC as a simulator, and it makes it really, really easy. Obviously, what you can do here, right, is you can come in and sort of add as many networks as you want. And this is what Kenny was talking about in terms of saying, okay, here is where we really set up. You can have one file and put a Quorum network in it. You can put,
Ethereum mainnet,
Ethereum mainnet,
Ethereum
Ring,
testnet,
Coven, whatever.
Can you-
And
Can you use environment variables here, or is this?
Well, this is just a Node script.
Yeah, you can do whatever.
Do whatever you want.
So if you have a list of networks, and I think you touched on it. Yes. How do you choose which network?
So you would see later on we're going to say truffle space migrate. Then it's just -- network space and the name.
Yeah.
So that name, so if you,
So it would sort of be like this, right? Like it's gonna default to development, so you don't need the network flag as the file is set up now. But like, say we went and made a Quorum network block, then you would have Quorum there. And like, generally speaking, what guys do for the most part, as far as I've seen, is there's already like a neat provider called Infura. If you guys don't know about them yet, they sort of provide you with like an endpoint that you can access, that you can use to access whichever network you want. So generally speaking, people will go and put like their Infura endpoints into each single one, so that like again you can use one file to migrate onto whichever network you want.
What's it called?
Infura, Infura.
another consensus point.
Yeah.
So
Snaps for consensus.
So apart from the network stuff, what else goes into the Truffle JS configuration?
It's really just network.
that is,
Just only the
yeah, that's its only purpose. Yeah. Actually, no. So there's a little bit more that you can do. Say, for example, you want to use a different like signing provider, and you want to split your signing provider and your, because this effectively sets up a RPC, the remote procedural call connection, the details for it. This is how you hook into your get node or your test RPC node or whatever, right? That's what we were talking about. So if you want to separate how you connect to the node, and you don't want to keep your private keys on the node, which you shouldn't do, you set up a different signing provider in here. I don't think we'll get to that today, but you can set that up as to which one to, or how that works as well.
Is it also like a URL?
No, it's actually just, you didn't actually specify it in here. You just specify the RPC part of it. So right now it assumes everything is on this part, and then we're actually going to use MetaMask. So it just knows that we're going to use MetaMask for signing. I think we're going to use MetaMask for signing.
Yeah.
So we don't specify that we're going to use MetaMask by not. Sorry, we are not specifying we're using MetaMask in this configuration, but you could very easily specify just the RPC portion of it in here. Okay. For example, if you were to point to a different network like Death, you would need to just think about how you're going to set that up. Okay. But effectively, all that you need to worry about in here is your network setup. Okay. Okay, cool.
Andy, what provider did you mention?
Infura. Infura.
It's pretty slick.
Yeah, they're probably the best out there. Like the MetaMask guys use Infura as well. So it's all sort of quite incestuous.
Sure. Careful, it doesn't work there.
Jeez, I think I'll take my laptop and no. But yes, the benefit of Infura is that it gets to learn, how do we make these networks long-running networks, and then learn from that experience. So, do you want to put that up on the screen? Or?
No. Just because we're doing a screen share, it's sort of...
Okay, but let's quickly actually just do that, and maybe.
So yeah, let's just write a quick. Even though this is not actually part of the tutorial, let's just write a quick network block for Infura, maybe on Robston.
No, let's not do that right now. I just wanted to show them. So like Infura handles 500 million requests a day. It's quite a lot. And like 120 unique IPs per second. There's currently 5 different networks actually set up to use Infura. I just wanted to show you some stats about it. But I think maybe later if we get to it, we can do that.
Okay.
But not right now. It's not hard. It's just we don't have anything to run against it even. So
Yeah. So it's not
we haven't even set up our pledge shop yet. So once we've done that,
then we can go. I'm getting a little bit ahead of myself. Right. So I think that the first thing that we want to do is if you go into the contracts directory, and just sort of check what's there. It's just a migrations.solve file at the moment. So if you will make yourself an adoption.sol file, this is going to handle essentially what we're going to be doing here is we're going to be writing like a pet shop with sort of 16 dogs that are up for adoption, right? So, and people can come in and use their Ethereum accounts to send an immutable transaction and make sure that they get to adopt the little doggy of their dreams. Right? everybody's got to have a pet shop tutorial at some stage. And I think, so this is actually one of the neatest tutorials that I've seen because it does provide all of this like quite useful front-end code that you can then go and adapt. You'll see like it's a pretty good looking thing in the end, right? I want to, okay, I can't really show you what it's going to look like because
But let's
I
see
can't
it.
stream.
Let's do it.
We should all be able to do it.
Yeah. So use your favorite text editor on this one. No, happens to be
But you
mine,
can use
but-
the edit if you want to. But
Okay, do you want to?
no, I'll use VI if I need to. But just yeah.
Yeah, I'm going to go with
It's fine.
mine.
Definitely.
Because I particularly like that. So the first thing to do in any sort of Solidity file is to set your compiler version. The way that we do that is with this strange word called pragma, Solidity, and then I'm sort of gonna Solidity. So the actual compilers are now, I think it's 0415. I think is the latest one. There's quite a lot of discussion on the go at the moment about whether the optimizer is really working as it should, and certainly like from sort of 0414 onwards, like I've had some problems on VMs with just like having my processors killed because like it completely chars the memory, and so there's like a little bit going on with the compiler. So we're just going to use 044 here. And that little copy beforehand, as you guys all know, right, requires 0.44 or above.
So just note, there's also quite a big change happening from I think 12 onwards. So there's you get the introduction of assert and require,
which we're actually going to use. Yeah.
Okay, great. Sorry, once again, I've actually gone through the tutorial. I should. So there's this move away from using throw, which just consumes all the gas, and to using actually a new opcode called it's revert. So and then that doesn't consume all the gas that you actually send to your contract for execution. So it's a better way of undoing. And then in future versions, currently if you throw, you can't see the reason why throw. Because it literally just undoes whatever. So you can't, if there was a console lock, it would undo the console lock. So with revert though, we hope to, you currently, I don't think it works like that, but with revert, you'll be able to specify a reason. So that you get onto the stack into a place that wouldn't be undone, which is great. So there's lots of work in making it easier to know what's going on in your code, but it's still early days. It's getting there.
Cool. So we're going to dive right in and start writing our contracts. So in order to do that, we just use our contract keyword, and we want to sort of, generally speaking, it's best practice to call your contract by the same name as your file. You don't have to anymore, but this used to be a requirement in Truffle, and it certainly makes managing all the things much easier, right? And then, like I say, this is going to be a very, very simple contract, right? But it's sort of worth going through in detail what each thing is and does. So let's just sort of take a look here. You can always sort of go to the actual tutorial should you require it. But essentially, what we're going to start by doing is setting like our address array.
Let me just quickly show you how to. So Control Alt and arrow key shifts between goal.
Cool. So we're going to sort of initialize some of our variables at first. These things, generally speaking, like defaults to public. It's something to really like make yourself aware of in Solidity. There's also like again quite a lot of discussion about whether that should be the case or not. Because like what a public variable means in Solidity is you have an automatic getter function sort of written for it when you compile it.
Yeah.
So
maybe just a little bit more on that. If you're aware of if you're used to the way of doing things, you'd normally have your variable and then you write a getter and setter for it. So you mutate and access it. In what Solidity does for you is any public variable, it will auto-generate a getter for you, but it doesn't do, like, for example, we're going to write we're going to create an array called adopters. It's not get adopters, it's just adopters. Or the most common one you might have seen is from the ERC20, like token contracts, it's just balance of. So it's just balance of, and then you pass the parameters into it. The setter though is not auto-generated, at least. So if you want to do that, you need to write your own one, and then normally what you do on a setter method is you actually restrict access to it, so that not anyone can go and update the value in there. Okay.
Yeah. Cool. So we're gonna sort of declare our variables first, right? And we're gonna have an array of 16 people because there's 16 pets in this particular tutorial. It's sort of worth, even though it does default to public, it's worth being explicit for your own benefits, right? So that you're aware of what you're setting to public.
And anyone else reading the code.
Yeah, exactly. And we're going to sort of call this array adopters.
And just a quick note as well, so address is actually a base type in Solidity as well.
Yeah, so I mean, you can think of Solidity as kind of like strongly typed JavaScript, but not really. Probably not a good idea to think about it like that entirely, but it is.
You need line endings. You can't have no.
Yeah, so it's important that's like I think that you're sort of explicit about what's private and public, both for yourself and for the people reading it, because one of the cool things that you can do is you can go and verify your source in some way like Etherscan. If you want to go and verify the source, for instance, for the meetup token that most of you should have now, you can do that. And it's sort of a nice way of being open and transparent. And then literally we just have to sort of write a few functions that will allow us to A, adopt a pet, and B, sort of see who has adopted a pet, right? Those are really all we need. And like you can see from this example, you'll see that this is only really going to be 20 lines long, and it goes to what I was saying about like trying to keep your smart contracts as short and as simple as possible and doing all of the rest of the processing on the client side rather than on-chain. So our first function is going to be to sort of handle the adoption, right? And because this is sort of strongly typed stuff, you have to declare your type, right? So we're going to have an unsigned integer for each sort of pet ID, right? And again, like it's worth sort of being explicit about whether this is private or public, and then you need to sort of declare a return function, and this also you need to declare the type that you're going to return, right? So we're just going to return the unsigned integer, like the ID of the pet that we've adopted.
Maybe just a quick while Andy's typing, another note about public and private. All that normally restricts is other contracts reading the data on you. Anything you put on a blockchain is viewable. So don't think that if you make something private, it hides it from people viewing it. It's just other contracts normally won't be able to access that. So for example, that is one way in which you can lock down some of your variables so that they can't be used by other contracts. Okay.
Cool. And so, I mean, generally speaking, like what you would do here is perhaps like write an if statement, to check that your ID is sort of within that 0 to 15, the 16 length array that we've done. But because sort of we've just sort of upgraded Solidity and we've now shifted across to these assert require statements, which use the revert opcode rather than throw, which A, both saves gas and B, makes debugging easier. We're going to use the require keyword, right? And all we're going to require is that the pet ID that we pass in is greater than or equal to 0, right? And that the pet ID is less than 15, less than or equal to 15. And then you can sort of shut that off. So that's actually also like the syntax itself is quite a bit easier, just a little bit cleaner than an if statement, right? It might not be quite as familiar at first, but that's essentially an if statement just written with a need require. Exactly. And I mean, they actually have asserts as well. So, I mean, it's old school.
So require you would use in your normal flow to make sure that you don't enter conditions that could happen. Assert is to make sure, say for example, you're returning from another contract call, that contract didn't do anything funky. So you actually require, the one actually uses a revert, the other one still uses a throw. So there's actually a difference there as well. So the one is a little bit more strict. You actually want to like kill everything that's been happening up to this point because the contract you're returning from is something funky, and the other one is you know, someone typed a weird ID in there. So no need to like consume all gas and kill it, you know, complete the street. Yeah. Even though we do undo, it's not I need to take all the gas as well away from you. Yeah.
So what would happen in this case if the ID is greater?
It would revert.
Eventually, it just jumps up.
It just yeah.
It just returns.
Well, yeah. So it doesn't return. Yeah, and then also I think I might be wrong, but I think require would then also put a one on the stack, so that if you say for example another contract called dysfunction, it would know that your execution failed, or your execution was an error. So it would put a one on the stack as well that can be and not a zero.
It will stop.
Yeah.
How will I interact with another contract? I know, maybe it's like, can I?
We can. What I would love to do is show you, just even though maybe we won't get around to deploying the ERC20 token, just go through the thinking behind it. And in there, there's actually like a reference to another contract, so I can show you guys. Yeah.
They have a really nice one there.
So revert is the more formalized version of the old way of just saying return to bounce out the function.
No. Okay. So normally you'd have a throw. The old way was just calling throw. But what the problem with throw is you don't actually know what happened or the reason for throw because you can't log anything. So there was this need to introduce a new opcode called revert. And so currently for revert you can't specify a reason, I think, but in the future you will be able to. And then at least, and the reason for that is you need to, because if you think about what the throw does, is a throw just, you know, everything that's been pushed into the stack, it sort of just, it doesn't do anything with it.
Memory size it also doesn't emit events or anything like that.
Exactly, everything is, so that's why there was a need for a new opcode, and then in addition with that, we also don't want to actually necessarily always consume, because if you give a contract a certain amount of gas to execute, in some cases that might be malicious, so you want to consume all the gas that the person has passed into it. In some cases it might not have been malicious. So in that case you actually do want to return some of the gas at least. Okay. The difference between that.
Yeah. Everybody happy with that? Okay, so the next thing that we sort of have to do is like make sure that the ID of the pet that we've selected to adopt is sort of set to us, right? To the person who wants to adopt that. So if you look in your adopters array at the pet ID that we've passed in, and we need to sort of set it equal to the address of the person who's sending it, right? And there's always sort of this message that gets passed along with any call on Ethereum, right? And you can, so with any transaction, right? And there's a bunch of things that you can access with that. There's message.data, and there's a few, there's four.
There's quite a few, right?
So you can do a lot of, but like generally speaking, the one that we use the most is message.sender, right? And this will give you access to the context of the person who sent that transaction, right? And it's literally, again, it's as easy as that. So
we have, so by using message.sender, this would be strongly tied to the entity that controls the sort of the private key that would have initiated this transaction. If this was another contract calling it, it would be tied to the address of that contract. And we can assume that part is always in place. So for example,
really
in some other contracts, what you want to do is, so this contract doesn't have a constructor. Everyone knows what a constructor does, right? Mm-hmm. Okay, so if
Constructors run a contract deployment,
sorry?
Constructors run contract deployment.
Yes, but the concept comes from other programming languages, right? So in a constructor, what you sometimes do is if you want to have like special administrative rights as the deployer of this contract, you actually want to like take message.sender and assign it to the owner, the deployer of this contract. And in that way, you keep track of who's allowed to do certain admin functions, like, for example, issue more tokens, or destroy tokens, or struct, like kill this contract, or certain things like that.
See, I think that's our meetup tokens have a constructor.
Yeah.
The ERC21 has what I can show a little bit later.
Yeah. So I mean,
So I know we're distracting quite a bit from actually just getting the stuff done, but I think it's important to form some other baseline for us to move. Because obviously this is also not the first time for many of you. Most of you would have written some code, at least in the past. So tying it into other coding concepts, I think that's useful for you guys, or do you just view it as a distraction?
Kenny, why does your Etherscan not show my source? Let's weird enough. Okay.
Yeah, let's maybe just focus on getting this done, and
Yeah.
then we'll show them the ERC20 contract a little.
Cool.
So
Cool, cool, cool.
it's pretty much like the global context that's
Being
sent
sent.
around.
It's one of the global contexts that is sent around. Yeah.
What are the globals are?
There's quite a lot. For example, there's a thing that you can just get the block number. There's there's quite a
But
few.
as properties have message?
No. So there's only a few properties of
This is
message.
message data, message sender, message
Origin.
origin. Yeah.
Is there a place
And there's
to
one
list
more.
the globals?
Yeah.
Yeah, and the solidity documentation. Actually, maybe we should have shown them this.
So let me read the docs. Yeah, this is a really, really great site.
Just paste the source to the Slack. if you
The
want.
read the docs. Sure, I'll do that.
Will you? Okay, will you do that?
Yeah, 100%.
So in here, there's quite a lot of. So you'd be able to, for example, search for. And then it will tell you, for example, yes, solidity by example, tell you have the message.sender. You missing global variables, it talks about. So there's actually message of gas, you can get the gas on it. There's quite a number of these things, but you can find them all in the docs. Ooh,
That's a little bit awkward.
that is very good.
The message.gas, so like I've not used this in live before, but I have a sense that this is going to be quite an important global variable. So one of the things that's we're sort of running into now as Ether becomes more and more pricey is that even with sort of some dynamic pricing stuff in place, like it's getting quite expensive to run. That's why Uport's going through this whole refactor of their identity contracts and trying to make sure that they have like a controller rather than deploying a new contract for each individual that signs up and whatever, because gas prices are actually becoming like fairly pricey. So like it costs actually I figured we don't need 200,000 gas for meetup token, but like it costs me about like $2.50 or so to send a token to anyone, which is not much, but if 100 people rock up to a meetup, right, it gets a little bit pricey pretty quickly. So like using message.gas is one of the ways in which you can sort of set dynamic pricing regimes, and that's pretty cool, right? And then you as the developer can sort of like fiddle with your code to try and make sure that's like you get both like the cheapest deployment and also sort of you can mess around with like how speedy it is, right? Because obviously the less gas that you're including, the sort of less likely your transaction is to be included fast. It will definitely make it through.
So that's the price you set on the gas.
Yeah.
The gas you'll need to execute something is fixed, but the price you set it like that. I just wanted to show it. And then there's, for example, message.value as well. And message.value gives you the Ether that is actually sent in this transaction as well, if you're doing stuff with Ether. Another very good resource for getting, and I'll share this in Slack as well, is learn X and Y, yes, for solidity. It's quite a cool just reference for all kinds of different things that you can like. Shows you how to do, the pragma mapping. Will you quickly paste that? It shows you, and then it tells you extended readable, not writable by users or contracts. It's quite a nice, just like dump. If you sort of I often go here if I forget the syntax of something. I often go to this site as a nice reference. So I'll paste this. Are you going to paste this?
Yeah.
Great. And this is actually a great reference for some other languages as well. And lots of stuff in here. For example, this just points to the address of the contract you were talking about. Some other globals that it gets passed in, like this with balance. So for example, if you self-destruct a contract, you want to actually, if that contract's holding any ETH, you want to just send it back, right? So that you don't lose it. So this the balance will tell you how much is left. You can just return it to the owner, for example. It's another reason for setting an owner of a contract. You can actually return anything the contract is holding.
And here's sort of what Kenny was talking about in terms of like getting your timing right. There's these two global variables like now and block dot number. So I mean, generally speaking, it's not good to use now because it's really like an approximation and like you're going to break something at some point, right? Yeah. Unless all you need is an approximation, that's fine. But like for instance, like these token sales that happen like very often, they set like an actual block number that it would begin at.
Because there can be no ambiguity about
like it might, you know, the time is sort of relative, as we all know, right?
So that is just while we're on that, and this is a little bit of a tangent, but like in IOTA, you don't have blocks. So what time are you going to use? IOTA uses Tangle as the. So there's an interesting thing here that's actually so important when you're writing your contracts. You know, blocks are this super nice way of knowing the order of things. If you don't have that, how do you establish that? So I don't know if Tango has a different IOTA has a different way of addressing that, but just something to think about.
If planning is super important, you probably want both of them, just in case two things are in the same block.
So remember, in the UTXO world, you can have stuff happening in parallel. In the Ethereum world, not. They're all sequential. One transaction and then the next. And that's even on a per account level. That's why you have a nonce per transaction as well. So every transaction submitted from one account will have a incremental nonce. And that's how it gets ordered around.
Do you guys see kind of an end of life for Solidity in the near future, or is there Solidity is going to be sticking around as the
Solidity. The thing about these projects are it's all community based, right? And the larger the community is, similar to how you can think about these networks. The longer they've been around and the bigger they are growing, the less likely they are to fail and die away. And Solidity has the biggest following of all the current languages that do compile to even and bytecode. It doesn't mean that we won't have others, but I think it's worthwhile learning. I do think it's worthwhile learning. It does change rapidly. There are like certain problems with it still that maybe makes it like easier to do stuff wrong instead of right. But I think it's definitely worthwhile learning if you're in the space.
There's a few things to be said about this actually. So, you know, I mean, the whole sort of idea and thinking behind Ethereum and blockchains in general is lower the barriers to entry, right? Permissionless access to innovate and all that kind of stuff. And Solidity, despite the fact that the compiler is a little bit buggy still, and there's some issues about like whether things should be public or private, and like some of the design choices that have been made, this is very familiar to people coming from like the web dev environment, right? So like if you have a little bit of experience with JavaScript, like you can write Solidity. You can't write it safely, but it's not hard. But you can write it, right? And you can start messing around, and that's massively important for like the community in general. That said, and in fact, like a nice example, like here, of one of the things that's wrong with Solidity, right, is that like we have to declare that address 16 because Solidity can't return dynamic arrays, right? So like we have to set it to that static array, and then Ethereum will actually go and initialize. You'll see in our front end code when we write some of the checks later, Ethereum actually initializes that whole array with sort of 0 addresses, right? 0, 0, 0, 0. So that's not perfect, and there are like lots of sort of little side projects on the go to. So one of the ones that I think is most exciting is they want to sort of have eWASM, right? Like Ethereum WebAssembly, and sort of use like the WebAssembly work to try and like make a sort of more compiler related like language for Ethereum, if that makes sense. And then there's also some guys like James Young and whatever who are working on visual programming languages for Ethereum, which I think is hella very exciting.
Very cool.
But I'd love a visual programming language for Ethereum. Whether we'll ever see that or like whether we'll see that in the next 5 years is debatable. But yeah, so like I think Solidity will stick around, and I think it has to stick around because it's an easy entry point for people, and like lots of relatively inexperienced devs like myself can understand and pick up the tricks of the trade, right? And I think that you'll find that like EWAS and whatever will be implemented, and it will be used by like the more hardcore people who actually really know what they're doing, and you know, and sort of find great advantage in writing sort of more kind of compiler like languages. So yeah, we need to sort of move on with this. We've only got one other function to write, which is very, very simply like the one that we're going to use to get our adopters, right? We're not going to actually pass anything into this. It's worth sort of, again, just denoting for ourselves and for everybody that it's public, and this is going to return our address array. That is,
Is using strings as keys anywhere close on the horizon?
not actually no.
Well, just think about, so it ties actually really into what Andrew was talking about earlier. You know, when you, it's quite hard to allocate things if you don't know what the size are. On a blockchain, you need to. So that's why you have to specify address 16 and not just. And similarly here, if you don't know what the length of your address keys are, how do you allocate something for it? So that's why using by32 is just, yeah, it's just so much easier. It's, yeah.
So all we're going to do in that get adopters function is, because we've already declared adopters up here and knows what it is, all we need to do is return our adopters array, and we'll get that address 16 back. And that's literally like the entire contract that we're going to write. I also want to show you guys.
Control Shift.
Yeah, exactly. So one of the other nice tools is there we go. Let's get some issues. So if you go to don't worry about the version string on the end here, just ethereum.github.io/browser-solidity. Right, this is sort of what you should get. This is a really, really neat online IDE. And in fact, you can use it to deploy contracts and everything to the network yourself. Kenny's just going to drop the link in there.
So it pastes on the version of that you're using.
Yeah, the compiler version that you're using. And it's just like a really neat way. So I mean, like I
think it's about that.
Sorry. It's a really, really nice way of testing your contracts. I mean, you know, Truffle is set up to do this as well, and if you run Truffle compile, which we're going to do now anyway, but it's just like a nice real-time like environment for you. And one of the things that I do sort of want to just show you guys is that like you have access to like a JavaScript VM, which is essentially test RPC that's running behind it, or you can use something like MetaMask on your injected Web 3 to sort of deploy onto the various different networks. Or you can, you know, if you're running Geth or Quorum on your local machine, you can use your Web3 provider and just literally like test and publish directly through here. And you can see, right, that's like we've just literally like put our contract in here. It is definitely compiling. We can create, you would see like a big red error if it weren't. It's just a really, like, again, you know, this is like to speed up developments, right? It's like you can test and iterate very, very quickly in an IDE like this.
So another cool thing that Remix could do for you is like warn you if you're doing something that is maybe a little bit dangerous, or there's certain checks you can do to scan for certain vulnerabilities and let you know about those. So recently, Etherscan has started doing that for you as well. If you view a contract that might have some vulnerabilities, like the meetup token, you see it, Etherscan just telling you about. We don't care about those though, but other contracts might need to. So,
Get a new tab going.
Control Shift T.
Okay, so we've written our contracts, and so we just got out of there, so you can see we've got adoption. That's the only contract that we're going to be working with. And essentially what we want to do now is just set up test RPC, which is our local simulated environments, and then we can begin. Do you have a mnemonic that you use?
No, I think it might be quite cool to show these guys. Trying to make sure
Yes,
that test
that's-
RPC isn't running anywhere else. I don't think it is. Let's just quickly. Sorry, because I've been working. Yeah. Okay.
You do have a mnemonic as well, so that's the one.
Yeah, but
that
I
use.
think we actually want to show them setting up on a MetaMask.
Cool.
Oops. Yeah. Okay. Can I show that?
Yes, please do. So yeah, one of the nice things that Quinny's going to run through now is you can these days, like they've done a lot of work on test RPC lately, and you can have a persistent sort of database that you can run it with. So if you run it with the DB flag, then you can like specify where it's going to write your data to. So like if you stop running it and come back to it at another stage with the same DB, like the contracts and stuff will still be there, which is really quite useful. You don't have to sort of like redeploy every single time, which becomes a hack if you do this stuff on a daily basis. And the other really, really neat thing is that like test RPC can be started with a sort of 12-word mnemonic, and that will lead to it generating exactly the same accounts with the same private keys each time. Right? And that's really, really neat because what you can then do is you can take those private keys, import them into MetaMask, and have them accessible in your browser and have like literally like a complete dev environment. So we're
And then that's quite a nice tie-up between how you tie it in MetaMask, which just signs your transactions, and test RPC that actually then runs your blockchain for you. Okay, so to do that, the easiest is probably to just start a new test RPC. It will do a whole bunch of stuff. So it will create a bunch of public addresses, a bunch of private keys for those, and it will spit out this 12-word mnemonic for you as well, and the path. So this path is where in the hierarchy you are referencing to with the index. Okay, so you can just copy this part, and then you can just kill this RPC. Well, I'm supposed to be able to kill it. Goodness. Oh well.
Why
Okay.
are you saying?
So you just have to close it, and sometimes it happens.
Okay, I haven't had that.
I have.
Okay, really?
Yeah. Okay. I told him about it, and he was like, "No, I don't believe you."
Oh really? That's funny. Okay, cool. So
It's because you're not just
Yeah, no, it's clearly been infected.
yeah. So once you have that in your clipboard and you have install, so add MetaMask to Chrome. But maybe just do that. So I'll wait for everyone to get MetaMask on the Chrome.
It's against metamask.io.
Which did you say we're going to use root or do you?
No, we
We're gonna
will use your test RPC. So
Oh, okay,
you're going to
so
have your
it's
own
not-
local host one. Yeah. Exactly right. Yeah. What is it saying?
So it's test RPC -n, and then
Isn't that your 12 words? Looks like. Very lonely. So you can just go to. Just say I've copied it somewhere.
Yeah.
Is this
so it'll run on localhost, and we'll put out that RPC port on 8545,
and then you go to your account.
which sort of matches the defaults in the truffle.js file, so you don't have to actually change anything to get it to work. We'll see, like when we run Quorum uses a different RPC endpoints, so like we'll just quickly.
Yeah. So just note, if you're using MetaMask to store any value, just make sure you keep your 12 words like safe somewhere. Because if you go through what you're doing now, we're actually connecting you to a different hierarchy of keys. Okay, so you're going to lose your ether if you don't keep your 12 words safe somewhere else. Because you're going to, after this, you're going to need to re-import it. Okay. Yeah.
You don't need to. So you also you don't need to import the whole hierarchy. Right? What you can do is you can grab, like if you see the output of test RPC in your terminal there, you'll see that the private keys are listed below the accounts. You can grab like one of them, and literally in your MetaMask as it's set up currently, you can go to
import
accounts, imports, choose the private key and paste it there, and it'll import just that account for you, which I think is
Maybe that's safer for you to.
safer
So
if
you're already using MetaMask, then maybe that's a bit safer.
So that's certainly what I do.
So
And then-
if you click on the MetaMask icon in Chrome, this pops up. You just click on I forgot my password. It allows you to set up a new.
Where is that? Oh, just lock it.
Yeah, if you really log in, just lock it and then. Okay. But if you're scared that you might lose your ether, just maybe don't do this.
Let's go for it.
So I know mine is backed up, so that's why I'm happy to do this. Backed up in several locations. So,
Do you put your main stuff into MetaMask? Do you actually use MetaMask?
I use MetaMask for small amounts to keep it in there.
Not large amounts.
No.
And I think Dan and Aaron would probably be quite scared of people who like storing huge amounts.
Yeah, no, this is not meant to keep big amounts, right? This is meant for your sort of day-to-day use. It's exactly for what you're doing now. Is you want to adopt a pet, but you need some ether to do something with or to sign something with, right? Then you use MetaMask.
Yeah.
Or
So what would be a good hardware?
Sorry?
What would be a good hardware wallet to use for that?
I think Ledger, the Ledger Nano is probably one of the better
They're
ones.
very scarce.
Well,
Yeah.
like that.
Right.
A software one.
Inexpensive.
Software.
So there's actually this brilliant thing called AirGap.
But you know, it is expensive. But if you think what you
So this is probably one of the more secure ways of storing ether. AirGap is pretty cool. It actually got sent out. If you guys subscribe to the This Week in Ethereum news, you would have seen this come up as well on the last one. So AirGap allows you to set up a offline computer, the online equivalent where you publish the transactions. The offline computers where you keep all of your private keys. It's quite cool. So then if you go down, it actually the steps. So you set up a signer with your offline computer that is never online. You can then prepare the transaction on your cell phone. And then Anyway, so this is probably one of the best ways to
It's
keep
very
it.
simple
To use as well.
Right?
I think so. Yeah. So I'll paste this in here as well. So when I set up my blockchain things, this like easy use stuff wasn't around yet. So this is I'm quite happy to see these coming out to make it super easy for people to keep the bulk of their funds super safe. Yeah.
Okay, so if you've got MetaMask set up and test RPC running, we can go back to so test RPC -n. So -n is the mnemonic, and then -db followed by a path will sort of persist your data.
Okay.
Password is just 1 to 9.
Dash in and then paste the whole.
The whole 12 word, in
So then-
double quotes.
So yeah. So then, but my test RPC isn't running yet, so I need to just start there. So this is how you test RPC -n and quotes. Oh, sorry. Oh, no, not that. So this is the issue with Jax, is you could view your seed word without the bit. So that is the reason why people are from using Jax. So just copy your 12 word, you start it, and then it will use the same tree to generate your public private key pairs.
So
For the mobile.
Sorry?
The mobile.
On?
That's mobile.
But Jack's mobile version used to also not require a pin. It's only recent versions that require a pin. And if you were running Jax on the old version, it doesn't by default, if you update, just have a pin, right? Because you need to set it. So if you're using Jax, make sure you go into Jax and set up a pin so that people can't just unlock your phone and view your private keys. Okay.
pretty important.
Okay. Sorry for being pedantic about that.
No, no.
Okay, cool. So now we have SAFBC running. If you go back to MetaMask, you can just click on. Is Fazana's just taking a photo of the
Super rich in my wallet here.
It's funny. So MetaMask sometimes have some like refresh issues. So even though mine was already set to localhost, it didn't automatically. So I just needed to click on private network and click on localhost again. Okay. Oh, okay. Now let's.
It could be because I don't know.
Cool. MetaMask, yeah, like it generally is very good, but it can have issues.
It can have,
which is why you shouldn't install too much Ether in it, but it's really, really great for development. Like this thing makes it so easy.
So then you'll see this account one is like initialized with 100 ETH. Yeah, that's what it is. Yeah. You might have a little bit less if like it's transacted.
You should have some, but like it just depends what account you've got selected.
Yeah.
But what's the whole
If anyone just wants to buy it from me.
And then, and then I'll buy it for you at 0. So then what's quite cool is because you've now connected the two, your SAFBC and MetaMask via this 12-bit mnemonic, you can now generate pretty much infinitely new accounts on MetaMask, and all of them will be tied to SAFBC. And the first couple of them will also already be initialized with 100 ETH for you. So if you hit this button, and you click on create account, and you switch to it, this will actually just create a new account in that tree for you. So then you will see this account number 3 also has 100 ETH on this one, on the little dude, the dude with the arrows. Yeah, and then it has different. Yeah. Does everyone is everyone up and running with MetaMask?
Mine's just spin.
It takes.
Just click on that.
So this is actually why we want people to pair and market each other.
All right, so we're away. I did sort of show you the IDE to that proves that the stuff will compile, but you can now sort of do it with Truffle as well. So if you just cd into your root directory, whatever you call it, pet shop or tutorial or whatever, and the first sort of Truffle command that we're going to run is Truffle compile. So this will compile your contracts locally. As you can see, it's compiling adoption and migration there, and it writes them right. It writes into sort of a build folder that your front end code will have access to. And if you go and actually have a look in here, you should see some JSON files that give details about your contracts. So there's adoption.json, and if I just cat it quickly, you'll see like essentially what's going on here is like you have the whole.
So Control Shift and arrows will scroll.
Oh, okay, cool. So essentially, you can see like this is the compiled version, and it has all our sort of methods and stuff in it.
So just to interject there, sorry. You tell me if you don't want me to interrupt.
No, please, I love it.
But the problem with interacting is we could end up talking about air gap and all kinds of other things, which is useful but not necessarily for getting through what we actually wanted to do today. So this is the API, and the API tells other contracts or other programs how to interact with your contract. So it keeps the API, and then if you scroll a little bit more down, it actually gives you the unlinked binary, and then the I don't know why. Oh, we haven't deployed it, right?
Yeah,
so this is why the network like object is empty. It tells you the version of the schema and when it was last updated.
And that's all information that's been piped back from migrations. So yeah, let's get out of there.
So this artifact that it created for you, you'll then be able to pull into your tests or your node index, your main script or whatever, and then actually use. So then you can literally do, contract artifact dot deployed, which will give you the latest one, and then any function you want to call it.
So
That's easy as that.
the next thing that we have to do is we actually have to write our migration script that we're going to do. So if you just go back into your migrations directory, which one would like to do there? So essentially what we're going to have is something called to deploy underscore. I think it is deploy contracts.
So just another note on the numbers there. The only reason for the numbers there is so that the order of execution will be correct.
Cool.
Yeah, because if you just get an array of files in a directory, you didn't know which order they're going to come in, right? So that's why we have the numbers in there. So the Truffle knows which one's the order of which is right. Yeah.
Okay, and then like this is very, very, very simple, and we're going to just move through it fairly fast if we can. So essentially you just need to set up a variable for whichever contracts you have. We've only got one, so it's going to be a job adoption, and so it's artifacts dot require. So this artifacts refers to the stuff essentially that's been compiled for you. It is, you need to have like your relative path, so it's in the same thing.
Is it in the same?
Yeah.
So it should be, right? It's not actually, but if it's because of the way that artifacts.require works. Because it's pointing to that artifacts folder.
The build folder
Build slash contracts. Yeah. And then literally all we're going to do is like module.exports. It should be sort of and we're going to set this equal to a function. And what we sort of pass in is only the one argument, right? This function only ever has one argument. It's the deployer. And you guys will see like this can get considerably more complex than what we're going to do, because you can be working with libraries, and if you are working with libraries, you sort of need to link them directly to your contracts. So I'm not sure how much longer that will be a thing for.
Yeah, that might change. But for now you need to.
But yeah.
So this is your build pipeline that you just specify.
Yeah, and as you guys know with build pipelines, like the more complicated it is, the more complicated these things can be, and especially when you start working with constructors and wanting to pass in different arguments to your constructors, and also wanting to use contracts that depend on another contract's address.
Yes.
You can handle all of that stuff here, and there are good
this file.
examples, but we're obviously not going to sort of go through all of that. And literally all we're going to have here is deployer.deploy, and sort of pass in our adoption. And that's literally our glorious build pipeline. So hopefully now, if you go back into your root directory, you should simply be able to run Truffle migrates, remembering that you could run it with the network flag, but because we've only got one sort of network object set up in that truffle.js file, it will just default directly to the local host on 8545. And that's kind of what you should see, right? It deploys the migrations contract first, and it gives you a transaction hash, and then the actual address at which it's deployed. And then it runs your to deploy contract scripts and deploys adoption for us. Let me know if you have a problem with any of that.
Is there any way for me to confirm that they'll open Truffle.js again, I'm assuming.
No, using command line to run this. Okay, you need to PowerShell. Yeah. So there's a known issue somewhat known issue on Windows. If you're using command line to run your Truffle stuff with it doesn't work. So like you need to use PowerShell. Some of those things do work, but I know specifically that this is one of the issues with it.
Okay.
Let me know if you don't come out. Okay.
Cool. So the next thing that we're going to do, sort of before we get into the actual front-end code to handle this stuff, is we're going to, like I promised, do our favorite part of everything, which is write a test. You can write your tests in JavaScript or Solidity. We're going to go ahead and write it in Solidity here, because I think that it's kind of a little bit easier to write Solidity tests for your smart contracts, because they're also in Solidity and Solidity.
What's the test framework that you're using?
So Truffle has its test framework,
Truffle
but
has
it's
its own
built on
test
Mocha.
Yeah.
So you can actually run. So for a long time, so Truffle was still a little bit buggy. I would actually not use Truffle because of it was a little bit buggy. I would actually just write tests and use normal Node testing tools, and you can very easily do that. obviously now, and it's going to take you through to a new way of writing tests. So I wouldn't be able to do the first one. I don't know, do they do the second part of testing as well?
No.
Do they only?
Yeah, so this is really just a solidity test.
Yeah. So there's actually two kinds of testing that Truffle allows you to do. One is contract-based testing, and then another is like normal tests that you would write.
Yeah.
So those are more, say for example, testing this contract's interaction with another one, and then a user's interaction, and so like a whole string of like functionality almost that you want to test instead of just like a function. So what we're going to do now is test that the function in your contract works.
Almost like a unit test.
Yeah.
Cool. So if you cd into the test directory there and make your file, we're going to call it test adoption.sol. Right, so and again we start off with the same thing as we did last time, so you just got to set your Pragma solidity version. I'm going to set it to 4 again just to be consistent.
I don't know why they're using 4.11 in the
I don't like that. And we're gonna need to import a few things here to help our tests out, right? And so there's sort of 3 imports that we need to do. The first is sort of directly from the Truffle stuff itself, and it's just in the certs.sol file that they've written. You can find the whole I don't really think that it's worth reading through. I mean, it is worth reading through. I should be better about tests. So definitely read through it. Here's a full list of the assertions included with Truffle. You can go. It's a really, really long file. This is kind of what it looks like. But you have like a whole bunch of things that you can do with it. Sort of read that in your own time and definitely care about it because tests are important.
I think you took them in it, so just go.
Okay. Right, so if we sort of head back into our terminal, the next thing that we need to import is something to sort of manage our deployed addresses. So again, like there's an actual deployed addresses.sol file. So, deployed addresses.
Let me just sorry, again, one of these tangents. What is quite nice about Ethereum is you can now start thinking about keeping some data that you wouldn't normally store on chain, but is useful to have on chain in a smart contract. One of them is deployed addresses, and this really helps if you're trying to update or deploy a new contract version. So say for example you have a registry of addresses where your contracts are deployed. By simply updating that registry to a new address, and if the rest of the network first asks, what is the latest address for your contract before interacting with it, they will automatically be interacting with a new contract. Yeah. So even though you're working with an immutable ledger that you can't change, there are certain mechanisms of actually just making it easier for people to start using new versions of deployed contracts.
I think.
Just mention the coding practices.
Yeah. So there's a very nice best practices coding README written by in part by Simon Duluvier. For those of you learning, it's
in the consensus repos, isn't it?
Yeah, like most.
Hilarious. So this is community. We're going to use that later. But if you come to the consensus repos, there's smart contract best practices.
Yeah, maybe you shouldn't open the consensus repos on my machine though, because I might show you some projects that.
I'm so sorry.
It's not like it's on YouTube.
It's not streamed off this.
That's fortunate. That's very fortunate. I was stressing the
Sorry, they can only see what's going on the screen.
So I put it on your machine, but anyway.
You should only see the projects.
Cool. So I mean, you go to the consensus repos, go to smart contract best practices. You can do that on your own machines. Let's not give Tony's game away. Okay. And then the other thing that we obviously need to import is our own contracts, right? So let's just get it so it's sort of run up in the contracts repo and its adoption. That's Right. So like this, I mean, tests are always like a little bit longer to write than the actual stuff that they test, right?
You should have some sessions with you.
Yeah, it's just like you sound very negative about it.
No, I'm really not. I'm really not. Tests are great.
Are you convincing answer yourself?
That's not great. I just don't do that. They're great.
Let's we.
Incidentally, you love your job.
No, I do. Come on, tests are important. Tests are very important.
Sorry.
Okay, so the first thing that we sort of need to do is that we need to test the adopt function that we wrote first up, and I wonder. It seems to me, right? It's sort of worth like going. We need to first sort of set up our adoption objects, right? So if you go like the strongly typed version here and set it equal to adoption.
So this is an example of how you would pull in another contract.
Default addresses
We'll have the address of.
So Ethereum, Truffle will take care of having whatever the address is of adoption currently on the network, the deployed version of the adoption contract. It will keep in that registry contract.
So if you have another contract, it's on C, so you can just say
Deployed addresses dot XYZ. Yeah.
If you manage all of that stuff with Truffle.
Cool. And then, yeah, like I said, we need to sort of write a function that will test our adopt sort of first up. So generally speaking, like just use camel case for these kind of things. So test that the user can adopt. I think it's probably what we'll go with first. We're not going to pass anything into this function. It's really just to test that we can indeed adopt. And then we start with our strongly typed again. So essentially, we want to sort of set up an object for our returned ID from the function that we wrote, right? And we can use our adoption objects and sort of way that we set it up there is we're going to pass in an ID of 8. It could be anything. You can pass in whatever ID you want between 0 and 15. You can also pass one in outside of 15 to test that will break things. Yeah. Right, and then all we need to do for our test is we obviously need an expected variable, and then this is sort of where we're going to use our asserts, right? If you just all we want to do is make sure that we're asserting that these things are equal, right? And then passing in the two variables that we've set up: returned ID, expected, and then some message to pass back in our console. And so let's go adoption of its ID as should be recorded. Does this make sense to everybody?
Yeah.
What we're doing? Yeah. Pretty simple stuff. So I think that's remembering that the public variables have these automatic getter methods. You can retrieve the address stored by this test that we've just written, and then stored data will sort of it will persist for the rest of our tests. So we can use kind of what's been written here to sort of write the rest of our tests, which is really quite neat. And sort of since the test adoption contract is the one that's going to be sending the contracts. You'll see we have access to a this variable, which we're going to use in our next function, which is pretty neat, and it's sort of a contract-wide this, as you would kind of expect in JavaScript. So the next function that we want to try and test is whether we can.
before we went the next test can we run it.
Yeah. So if you just go back into your root directory. And it's literally as easy as running Truffle test. and you'll see that it defaults to that development network that we've got set up in Truffle.js, and then it compiles your contracts for you. It actually deploys new contracts onto test RPC, and that's why that deployed addresses and what Kenny was talking about is so important. You can see, like, this is obviously not in the tutorial. We're running into a few shadowed declaration shadows in the existing declaration. I'm not entirely sure if I'm 100%
Yeah,
honest.
I think let's maybe not go down this path right now.
Yeah. What's really important is that like our test passed.
So yeah, just to be so these aren't things that should be ignored, but I think it will detract from where we are right now.
Yeah, and I'm kind of so. I mean, you can see that it's coming from the assertion
Yes,
library,
exactly.
right? And so what I would do in this situation is jump onto the consensus stack and have some Coulter and tell them that this library is out of date. That's Anyway, so let's carry on with the.
It might even be because we're using a different version than what the tutorial is using of Solidity.
Should we
try
give it a go?
quickly see. I'm actually interested to know.
If that's what. So the. Yours fails?
No, because it says surprise. You can't even find the assert and deploy the address. It's not solid.
So if you. So let's just see what happens with the compiler version set to 0411. So we will figure that out, but let's just carry on with the rest of sort of writing the.
So let's quickly just for the guys that have compilation errors. See what's happening.
Yeah, grab some coffee while we look at these compilation errors. Yes.
Do you know what assert.throw or revert is? How do you assert that it reverted?
How do you assert that it reverted? I think that's. How do you assert a reversion?
Let me quickly look at the documentation.
Yeah. I've just.
I think around was definitely.
Yeah, so I completely understand the use case. Literally, like they switched across to using acquire and revert and stuff 2 weeks ago. So I haven't actually used it like in anger. I haven't written any tests that would look for a revert, but there should be like an assert.
Supposed to be there.
Yeah, just quickly show me
tests for a bit. I'm not great on the you guys are getting a deep look into all of my failures.
Testing, we joked about testing, but it was not easy.
Yeah.
It's something that gets quite overused.
Yeah.
Not just.
So there is definitely a way to do it, though. I don't doubt that.
No.
Mine says over there, you can't find the.
If you do find it, will you just post it in the channel?
Yeah,
That's awesome.
Can we just stop the SAFBC and you can see if that fixes things from your side? He's getting like not enough gas.
Not enough gas for what?
Just for this test.
I knew you were thinking
Not enough gas. We're not even.
We get plenty.
There's a different you're running on the test.
Yeah, not a doubt.
But maybe that's worthwhile checking from Truffle. Just quickly go to Truffle.js.
Exactly, and that's the sort of the link that I showed you. It's a long one, there's lots of libraries and stuff involved, but it's definitely somewhere in there.
That might be just open your test adoption yourself.
Looking to the events, it's
I just got and pasted the video, so maybe it's different from what I
I
first
remember when
time.
they introduced the second part of every line. I remember because I've written this code.
Yes.
Previously I worked.
And then
Next day I went to
So,
but they don't tell you what the error is. They're just like, there's errors.
it's everywhere.
They remember that
Yeah, that's what I got.
Yeah.
underscore thing?
Yeah.
Underscore thing?
Yeah.
So between that and that, it's just like
It can be quite frustrating, right? Like constantly having to keep up with the changes and whatever. But it's just the nature of being involved in the beginning. Yeah, it is the trust that you. I can't tell you the amount of times Jean will tell you, like literally, like I've had something working and literally like working on the mainnet, right? And then it'll fall over. And in fact, like one of the things that I ran into is the certificates module that we wrote to sort of handle the IPFS storage and everything. Like that thing works perfectly.
What is this now?
On the certificate module that I wrote.
Oh,
like
yes.
It works absolutely perfectly on Robston and locally, so I tested everything, done it all. And then you deployed it, like I deployed it to mainnet, and it turns out that like somewhere between MetaMask and Infura, they sometimes handle the transactions slightly differently on mainnet than they do on Robston, so they don't return like the transaction hash at first. It sort of comes back as undefined while it's sort of being processed. And so then like I couldn't update like the UI with the transaction hash. But these are the things that we get past. Yeah. I mean, you know, the thing is, this stuff is only what, like two and a bit years old, right?
Around.
Yeah. So let's not complain too much.
Was everyone else able to at least compile and test? So I think that because testing is such an important part of your development pipeline. No, seriously now. I think it's important that everyone at least gets to the point.
Yes.
Maybe continue with the other functions that
Well,
I'm testing. I'll help the guys that aren't able to.
Cool. So the next thing that we want to do is we want to check that we can get an adopter address by pet ID. So if you go test get adopter address by pet ID, which is not a very nice name. We're also not going to pass anything into this function. So we're going to declare sort of two addresses here, right? Address that is expected is just this. And again, that's because now that we've set it initially and we know that test adoption is calling it like that, that's a contract-wide variable that we now sort of have access to.
This is the add-on.
Yes. Yes.
It's just not. It's very dangerous. In my mind, it's very dangerous.
It is. It is. Yeah, exactly. I'm also like, I'm not a major fan, but like it's pretty neat that it's contract wide, and like if you have like a good understanding of what it is you're actually trying to test and what you're aiming for, then it's good.
So isn't this the test or not?
Sorry?
Is it when you call this as
He's gone ahead on this course.
Yes.
It's like it is this contract. Yeah.
which is test or not?
Yeah.
Open your test adoption.
So I just saw in the documentation they had for throws at least.
Okay.
There's like a little stuff you can do for throws, so this should
Yeah.
inject.
Yeah, so I know that like the throw stuff, but it's just the reverts. I'm not 100% sure.
Yeah, it's
on
not.
how to check.
Just to be able
And like I say, that's just because it's been implemented literally in the last 3 weeks. Yeah. How to actually test for a revert, because we know how to test for a throw, and that's sort of detailed documentation available on that. But I'm not exactly sure how to test.
What's wrong about?
How would you test for a revert?
What do you mean?
So like in this one, we've got like a cert.equal, right? And we test the quality. You kind of
what you should always do if you're returning from another contract, you should check the result of that, and there should be a 0 or a 1 on the stack depending on what you were busy, the outcome of it is. Yeah. And whether it passed or failed, 1 if it failed, 0 if it passed, then you should execute different logic, right? So that's how you should always. So you'll actually see like Simon, he loves doing sends in an if. So you do the send in an if, and then if that send worked, then you do something. If that send failed, then you do something else. Okay. Is that what you guys were talking about, the reverts and everything?
Yeah.
Okay.
kind of.
Did it pass? Did it work now?
No, it didn't.
What is this? What is it saying?
Okay.
So the return ID should be 1.
For those who are still
No, it doesn't work. It's just stop the test RPC as well. Yeah. We'll look into it later.
Yeah,
It's just going to derail what we do.
so the other address that we're looking for here is the adopter. And again, we're just going to sort of access it in the same way that we did in that test. We might as well stick with that.
So get the same thing. I still can't use it.
So,
And then again,
Yeah, but just, and if you're at the bottom,
Yeah, I did pass this now.
if you can guess what I'm going to write next, it's probably good for you.
but just start with this obviously or give me money. Yeah, actually, this part of it's not that important to have in
Let's sorry, swap those around.
Oh yeah, 411.
Um, so yeah, we just sort of set up our two addresses there, the address of this contract and the address of the adopter, and we're checking that it is indeed recorded and everything's handled sort of as we expect it to be. Got sort of one more test. Buddy, do you want us to run this and check that it does work? So let's just run that particular function first.
You can see it. Where now? In your so you need to so you can't log from it, but you can use the event.
Excuse me.
Okay. And then you just show the event. Because remember, there's no like standard out.
Yeah.
For a
I was
blockchain.
hoping
For a
that
standard thing.
Yeah.
But yes, no. The best way to get information like that out is an event.
Sorry, it's not adoption.adopt, it's adoption.adopters. That's sorry.
The Gary had a similar. I think.
Yeah, because initially I was typing my instead of copy pasting from the
Is
tutorial.
it working now? No.
So it's just
Essentially everything is saved.
The next set of functions are
But you
getting
can
much
see
longer
that.
to type. So
Some of it, and then maybe make sure that you.
so we're not going to write any of the UI stuff that comes directly from that box. And it's really like this testing stuff is the most important there. Like we're still getting all of these weird shadow declarations, but yeah, that's at least
Although
things
tests
to
should
test
actually
so
normally
far.
do everything for you. Even that's not
Just on testing. Why would you do two alternative scenarios for testing a contract? Because I'm assuming because the test is executing the blockchain, it means stateful data is persistent between tests.
Yeah.
So what happens if you want to execute it differently?
You could just
Just write two different contracts. Yeah, or two different accounts.
You did
Basically, I'm
a
asking if you can redeploy the contract midway.
they do have before hooks and stuff. They do have hooks like you would get in normal markups. So I don't know if you can just literally say take down and start it. So you just would literally use that before for that.
Oh wait, where did you? Oh, okay. That's maybe.
Again, I haven't actually used hooks in my tests, but I'm aware that it's a possibility.
If you look at normal
Just looking at the test directory, trying to run something.
always just have a clean state for
Yeah,
every single
the test
test.
directory, these are the parts where you are
Dom.
the self-help.
Most people don't do it.
Yeah.
Also, I have more than one test contract. So
Oh yeah, you can have as many test contracts as you want.
and
Right?
each one will
That's
get
what I'm saying.
redeployed.
Yes. Yeah.
So where are we actually deploying the contract in this test? I'm assuming that
Onto test .bc.
Also deploy
Yeah.
address and
Oh, and now
Yes.
run it.
or is that in the import line that it's telling it to deploy?
So that's
So,
it's a little bit weird, right? You put a contract as a
I think
test,
that you'll
but
find
yes,
that's
what it does is
like that imports, like it does deploy a certain deployed addresses onto your local version of test .bc so that it can manage it. I can't imagine anything else happening, right?
I'm just curious about like an edge case where it says you want to deploy the same contract twice. Very, very rare edge case, but it's possible to do that through the tests, or would that be something?
What do you mean deploy the same contract twice? So deploy a test and take it away and do it again.
Well, if you want, say, two of the same contract interact with each other, say you're testing how a wallet might behave if one of its signatories was, well, it's a multi-sig wallet, so one of the signatories is not a multi-sig wallet.
So in your so remember there's two ways you can test. You can test using the test contract.sol, where you test the like functions of another contract, and then there's also normal .js tests you can write. So those tests I think are a little bit more catered to the second. And in the second way, you can do anything that you do in a normal application. You can even you should, in that build pipeline, you even specify the two different contracts that needs to get deployed. You pull in the two different artifacts in your test file, your JS test file, and then you can run tests against them. Okay. All right. Cool. We all sense.
Okay. So the last one that we want to sort of do is we want to sort of test that we can get our adopter address by pet ID in the array, right? In the actual array. So again, this is sort of going to be an empty function. And like again, we're just going to be testing addresses, right? So like our expected address is again equal to this. And then like this is an interesting one.
All it does is make this one bigger.
We want our address array, and we're going to use the memory keyword. This is quite an interesting, and I'm sure that Kuni has lots to say about using memory. Right, so essentially what the memory keyword does is it tells Solidity to temporarily store the value in memory rather than in the contract storage itself. Right, so you have like ready access to it. It's kind of like a cache, right? Like,
so remember, everything that you need to store on a blockchain needs to sort of allocated and paid for. You don't obviously want to do everything on that. If you think about your EVM as it's executing, certain things come and go. They are transient. They don't need. And then having the memory keyword, they just make sure that you don't pay extra gas for it. There are some issues. I know from personal experience of like being stuck on something for like a whole day. If you're using structs. Sometimes the conversion between memory and storage doesn't work so like that. But there's many Google and that learn Solidity in 1 minute starting about that. Like exactly how to do that. Okay.
So we're gonna set this equal to like our adoption, and then we want to use the get adopters function, right? Does that make sense to everybody? So essentially, like with again, like our contract is expecting this address, and initialize our array, put it in memory, and then set it equal to whatever the return is of get adopters.
Does memory not get pressed through the whole network? That'll only happen on the machine that you have.
As far as I understand it, yes. And like Kuni says, right, you don't want to have to go into the contract storage every single time to retrieve something, and so it just sort of like pops it up here that you can like work with it, which is a bit of an iffy explanation, but this is how it's like I see it in my mind. Right? Does that make sense?
Yeah.
Cool. And then we're just also gonna like essentially just assert that these two things are equal and it's a message, right? So sorry, we should have not just adopters, but adopters at our expected value, right?
So have you?
And then our message.
If it's not in here, what you can obviously do is remember this is linked to sort of taking a learning from a happy farm. So it just makes me cringe. So if you go to the other
it's so bad. Like you're searching for what is there, but what about all other physics? You're not checking for it as well. They're not. You're just assuming you're empty.
It's a logical flow. So you're testing what you're doing in test one.
Yeah, but do they go to negative testing because you're testing?
No, but you would build your negative.
I know, that's why I'm making change.
Yes.
The problem with demos is people that don't use this demo, they start writing tests like it, and they started with, So, but it is, I do get that it is just a demo and it's just getting started. It's not how you got
It's certainly not how you would write a full test suite for your contracts. But,
set
This stuff was not. See the tutorial, even though it's a handler document.
So yeah, if you've gone through all of that,
And I put the wrong section in the wrong section.
we can test our last one. It's probably going to give us all these nasty errors, but we hope to see three passing tests. And like we say, I mean, obviously it's pretty important to go and read those Solidity docs and check that you can actually sort of write some negative tests and write a complete test suite. Because it's also like it's important to understand some of the sort of you can see like even in a very simple contract like this, there's a lot of nuance about like how that adopters array actually gets initialized and what's in there and how you test for it and how you make sure that there's not funny stuff going on. There's a lot of complexity that gets sort of hidden from someone who wouldn't otherwise know, right? And who hasn't had the pleasure of writing lots of motor tests before in their life. So, like our 3 tests are passing, which is really, really cool. And now, like essentially, there's a whole bunch of. I think that we're going to need to move on to Quorum, and I don't want to sort of run through actually putting in the front end code because you can find the rest of the front end code that you need to put into that source folder here. Like essentially, like once you've put in the front end code, and it's really just a case of what essentially you need to do in the front end is you need to like initialize your Web3 objects so that you can get like the provider that will both sort of fetch your accounts and will like act as the provider for interacting with the contracts. You'll see that you can like set your provider for each contract. That's an important thing that you have to do in your front end UI. And then like it's literally just a case of like going in, and you'll see in that tutorial they literally go into each function which they've set out for you and like putting in like the appropriate JavaScript code to go and talk to your contracts, which is really like there's a specific sort of form that those things take. They work with promises, so essentially like you'll go and like having set your provider for your contract, you'll then go adoption.deployed and then .then, and you can work with like the data that's being returned from your contracts. It's worth going through them and checking that it does sort of work and that you can get it to work. And then like once you've done that, you can sort of like they've got a really nice dev script. And don't worry, the camera is not looking at it. This is sort of what that front end looks like, and you'll see.
It actually would be nice to complete that. But I do agree we need.
We really need to move on. So
we had an hour and a half left.
So what you see, like when you click adopt,
maybe
you should see.
you want to like with your own account screenshot, because everyone, the rest of the people in the room can't actually see what it looks like.
Yeah.
It's part of the tutorial.
Yeah.
I think
Except when they say adoption and then the gas.
Oh, goodness.
Gas exceeds or whatever this. I don't know what that is.
But maybe paste those things, those problems you're having in Slack, whatever, and you can look at it maybe a little bit later.
That's what I'm
Nice. Yeah.
And you should. I'm just checking.
Okay.
Yeah, you
So
should. You should be able to like when you click on adopt, you'll see that nice little like signing thing from MetaMask pops up, and that's how you can sort of sign your transactions. And having sort of submitted them to the network, you'll see that like with your front end code, it sort of updates the button there and it says pending now, right? Which is sort of as far as the tutorial takes you. You would obviously then like upon receiving transaction confirmation from the mainnet, you would then update your UI and off you go, right? And the reason that they only sort of go into pending there, and it's something to be aware of, is that like when you're running test RPC, everything happens like really nice and fast, and it's really awesome, and you begin to think, hey, like this is super awesome, and like Ethereum's so fast and responsive, and then when you go into the mainnet, you find that you actually sort of end up waiting kind of like 15 seconds for things to be mined.
And when you move like the full site to using Raft consensus, then it's nice and quick again. So maybe shall we take just like 10 minutes break or something before we dive in?
Sure.
But before we do that, I just want to say I think what we like to show, what we wanted to show was almost a full end like application, right? And you can see it's actually pretty easy to start to get going. And you think about the implications of this. No third-party provider anywhere involved. From storing the keys to running the website. I mean, this is quite cool stuff that you're now able to start playing around with. And I encourage you to start thinking about what you're now able to start doing in this like Web 3.0 tech stack. Yeah. Cool. But let's take 10 minutes and then we dive into a little bit more of Quorum.
Enjoy the rest of your day.
Yeah, cool. Was it a little bit useful? I mean, you would have known most of the stuff.
Different kind of genius, right?
Cool.
Store the mnemonics somewhere, and test RPC -n double quotes
I think
mnemonic, and it's giving you a different one.
But the two other ones are using the full group. Yeah. The reason why I want to work since it's historically it's just because on the proof of work network,
That thing,
all of a sudden,
can I tell you the thing that upsets me most about Linux capital? So like when you SSH and you have to like SSH with like a specific port, little thing. When you SCP on the same thing, big P. So literally that thing was sucked like an hour of my life away from me. I was like, why is this not working? I'll send you an invite. I think if you
the consensus mechanism is much more
what's your email address? Kevin Feng at Capital Bank. Close it. So, thanks.
But I actually haven't used the service.
It's just
So I don't know the time.
Like we did last night.
It's had multiple. There's the same one that it started with.
We did the same
time.
That's
Every now and then it's working to go out or something.
it divides.
So even on Bitcoin, because you don't have to manage for the Bitcoin that you get, not a lot of people are mining it.
Keeping a close eye on
Ethereum.
at this stage,
And that's it's quite important to note that that's happening in the space. Because you now have these private blockchains that busy, and I think there's actually been quite a lot of work done that is abstracting the consensus so that you can hot swap almost. It's not like it's which also makes it, I should say, a typical on Quorum. So you can deploy new smart contracts and actually have an entirely new consensus. Not with Raft, but with Quorum technology. Raft is it's a very fast way to achieve consensus, but it doesn't work in like an adversarial environment. You have to have a little bit more fast because it either gets elected for a term, like say the next 100 blocks, and that tells everyone what the blocks are, and then another you can get so because in because it's still busy being developed, it's not like a smart contract. And there's like this called why can't we find more Quorum chains. That's the Quorum. We'll be using probably the Quorum chains. I'm sure.
Yeah, we call it. There's a
So that's why you can
Oh, yes, yes,
yeah. So then you can have like one blockchain and one Quorum consensus. It's a little bit like if you have one block maker, if you have multiple block makers, then you want to like with the raw, you want saying what the blocks are. People run experiments.
So if you want to count how many eyelashes are
So then you get very high speed.
On what side? That's obviously very contact.
I listened to the
No, capacity is really important because remember, once a leader gets selected, that leader tells you the order of the blocks.
have to leave because the gate
So even with latency, it's not that
and then
big
you
of a
have 3 runners standing in front of the gate.
Everybody said everything.
Sorry?
Also, everybody said everything.
No. So the leader gets the transaction, aggregates it into a block, and then tells everyone what the blocks are. And the transactions. Yes, but that's why the difference is such an important difference between using now and the block number is the block number is always guaranteed to be increasing. The block number that so at whatever, like I can execute block number 1000 at 3 in the afternoon. If you shut your node down and you spin it up again, you might be executing block number 1005 or doesn't matter. It's just, so currently, in order for everyone to have like a fair chance of building the next block, Bitcoin has 10 minutes to block. And if you're 15 minutes, super line but because you don't need that as well, because you elect all the releases for all the blocks, you didn't lose that amount of time.
I flew down yesterday.
Yeah, but you said
Oh, sorry, yes. Sorry, yes, it's hard to understand what I'm talking about if I don't actually tell you what I'm talking about.
So how does the user get
elected? I think just majority. So there's a so like Boeing uses Raft and they
It's basically
across all of their thousands of you use some of Easy to understand. I mean, like Paxos is quite a I'm just exploring Paxos as well. We're made fiat markets. Sorry? We're made fiat markets. Individually. No. We are, yeah. So we. Sorry, how many people? Sorry. Oh no, I'm not. So we currently I'm just sharing my screen. I'm actually. We're an active bunch of people. Then once one expires, see if I can get my you'll eat the back. Guys, can we get back to it? So let's quickly just. Sorry. No, it's fine. We're not getting around to. I do think have a bit of a base is sometimes better. Oh no, it's super important.
The problem with live micro.
Do we have any of these VMs? into the rest sessions.
Let's do that.
To me, scanning is not even they also so when these are like we're talking about something.
The problem with using your own machine is just firewall routes. So I don't know what Ince allows, like what type of incoming traffic Ince allows.
Ask the man in the corner that we allow it all.
So I've already set up a network. So what I've done on Azure, is I've set up a network security group with the correct firewall rules already in it. because of the, well, in part because of the new consensus mechanisms. Okay. And let's just quickly speak about each of these. So the privacy that comes with Quorum is achieved through something called constellation. And I just want to stand still on that for a couple of seconds. So in Ethereum, you have something that's called the public state tribe. It's just a data structure that has all of the variables that are on chain and their current values. And that is what you have consensus about in the Ethereum blockchain. So that you have consensus on this publicly known state tree. Okay. The problem with that is, like I said earlier, even if you make your variable, even if you change variables in Solidity between public, private, and all of that, it doesn't affect the state tree. In the state tree, everything is viewable. Anything that's in there, anyone else can see. It's not settable by anyone, because only setting them would be governed by the logic that is in your smart contract, and that logic is then obviously executed by, say, for example, a specific private key tied to that. Okay. What Constellation does is it splits this public state into a public and a private state. Okay, does anyone, is that clear? And because of this, what you can now do is you can create a constellation of peers, a subset of peers that you have consensus with on a specific private state thing. Okay, so that's why in test RPC, you can do everything that you normally do on the normal Ethereum blockchain, because your node is exactly the same as everyone else's nodes, barring private keys if you keep your keys on your node. Okay. In Quorum, that's not the case. So Quorum, you can test everything apart from, except for the constellation part, on using test RPC. What you can do with Truffle, which is quite nice, is you can switch between different nodes or networks, and just have those networks point to different nodes very easily. And in that way, because we now have this private state that will differ between the nodes, so that the public state is the same on every node, the private state might be different on every node depending on what has been happening on the network. Because you now have this private state, you need to just switch between different networks to test, or different nodes, to test what is currently on that private state, and execute against it. So once again, Truffle allows you to switch between different networks or different nodes that you test that. And that's actually how we did some of the testing for the work we did with the MAS as well. We actually just use Truffle, we switch between different nodes, and we test some of the privacy stuff. Okay, just a little bit of a aside, but I think it's very important to understand that part of Quorum. Okay.
So just to ask a couple of questions.
Sure, go for it.
Understanding. So when you say, so Constellation is just an extra network, right? Extra network connection between the two that then manages that private state communication.
Yeah, it's not a separate blockchain, but it's a separate off-chain network. Communication network.
And then it holds it, like, if I can use a very...
So I'll go a little bit more details into what Constellation does in a second. This diagram, this architecture diagram, shows exactly how Constellation does some of the things. What is not so clear on this is what I've just spoken about, the separation between. It is there, but it's not like highlighted. Because a lot of people don't understand that.
You can have multiple private networks, right? Per node.
Yes.
And it obviously then segregates every single one of those. So
it does.
it's like the public stuff and every private network.
As a matter of fact, every transaction you do, you need to specify who you'll be sharing this update or contract with.
And that's a private for, right?
Private for, exactly right.
You can have a private for, right?
Yes, you can.
Okay,
so in the private for, you by default are automatically included, and then you just give other people's Constellation public keys in a comma separate array to specify the other people that you are. And what you could even do is you can deploy a contract to everyone as in your private for. Right, and then, say for example, only Theo and I want to update something in that contract. I can do a second private for transaction, but talking to this contract that was deployed in the first transaction, and just specify myself in here. Then we will see the variable updated to a new value, but everyone else will still see the old value. You can even do that. You can, yes. Very powerful though. I mean, think about the use case, right? A bank often has a lot of private information that needs to be sent with a public transaction. Now you can't, but this provides a perfect mechanism of using the same end public Ethereum address to have private data shared with it and public data shared with it. Right? So you're talking to the same public-private key pair, same one. So, for example, FirstRand has an address and Standard Bank has an address. It would be between them in terms of public information that we share, but then private information that we share to the same address, you will then use it, obviously, FirstRand's constellation address, not the. Okay, so there's a public constellation key, and then there's obviously the public address that you have as well that we've been talking to up to this point. Yeah.
So if you think of a payment, you need a payment to be verified by all nature. Otherwise, how do we know that no one will know double spend? But when you do a payment in the real world, there's a lot of identity information that has to do with that as well. So in the Bitcoin world, we don't know too much about that, but in the banking infrastructure, you have to adhere to the AML and the KYC. So wouldn't it be nice if you could have a public payment that everyone agrees that's the amount that's been paid, and you can share that with those pieces as well, but there's a public component to it. And then from the same address, sender to the same receiver, you send all the KYC AML information. You don't need that to be shared with anyone else, because no one has to confirm. There's no unspending of that. It's just simply metadata associated with the payment. On the receiving side, they can then use that metadata to determine whether they're happy to receive the payment. So if it's coming from some of the large and some of them may say no thank you. But if it's legit and the source of funds can be validated, they say yes, we'd be happy to receive the payment. So the two are very nice, and there's a lot of scenarios we found where we want the ability to send metadata or extend the data of the transaction by having this private payload that goes just between these two. And you don't actually want copy and all those things, because you definitely don't want that leaking to anyone else.
Yeah. This is Quorum, right? So
it's Quorum.
But it's not in any way, shape or form available on public.
No.
Well, it's available in shape and form through the Whisper to be exactly the same.
Yeah,
sure.
Yes, but you have to then set that up.
Yeah.
We can't set up for you.
Well, you need to specify the Whisper flag when you start to get node, but it's simple as that.
So some of the work that we're looking at doing now in 2 weeks is to take some of the ideas that we've done design using Constellation and say, could we simplify it using Whisper? Which is available in public.
And there's a lot of work happening on this. Yeah. So unfortunately, I think what we will see today, once we get to actually looking these things up, we're still using the older version of Whisper, but more stable. We might, once Quorum upgrades to 1.6, there's also the upgrade of the newer Whisper to 1. Yeah. So then you'll be using the newer Whisper version.
It's Whisper V5.
V5 actually, not 1.5. Yeah, so currently we're still on V2, I think. Because Quorum is still get 1.5 base. Okay. So this is quite cool, right? You have get that it's been running for a while, and it's developing, it's adding Whisper, it's adding Swarm, it's adding whatever, and now Quorum is just another thing that's added on top of it. And now when Quorum updates to 1.6, automatically you just get all of these new things that come along with it.
Yeah.
Okay, and this is how this ecosystem is able to move at the pace at which it is moving, because it's not one company. It's not even one big company. It's like several big companies working on this. Okay. All right. Let's move on to the consensus mechanism. So no need to do proof of work, proof of stake in the permission network. Quorum offers multiple consensus mechanisms that are more appropriate for consortium or private chains. Okay. So one of the mechanisms is called Quorum Chain Consensus. It's a smart contract-based majority voting consensus model. And once again, what the Quorum devs have done, which is so cool in this regard, is this whole consensus mechanism is run on a smart contract. What that means is you can deploy a new smart contract and actually change your consensus mechanism on the fly. How cool is that?
And literally on the fly. I still don't know if I really believe. But I mean, literally from one block to the next, you can switch out your consensus.
Remember, you need to have consensus on the smart contract, right? So by definition, if you change the smart contract or a variable that is kept in the smart contract, you have to update your consensus. And because everything happens, yes.
Yeah. And you would have to pre-build it into the contract.
No. So remember, if you change the contract and the address stays the same, so this specific one is deployed to a special address on the Genesis block. Then you'll be able to update, which is quite cool. Yeah. There's a little bit more setup work done from what we are using today, but it's very able to do that.
Could you just repeat that? When you want to update the contract by which you achieve consensus, would it not be a case of deploying a new one and changing the address at which you're pointing?
The problem is that address is set up in the Genesis block right now. So then you can't. So what you would need to do is you'd need to obviously have a registry contract that contains the consensus mechanism that you're busy using. And then you can deploy a new address.
Yeah, okay, cool. Because you can't just send updates.
Yeah, exactly right.
So, like,
Not
just
without
trying to
access.
trying to understand the mechanism behind changing the consensus in the network. So, doesn't all the nodes in the network also need to subscribe to that consensus before switching?
So what you would normally do is actually have a grace period as well. So, but I mean, once that contract is deployed, then all the nodes have it, so you can start using it.
The nodes actually say we are
Okay. Cool, but yeah, very cool that you actually can now, and you can see other things moving to smart contracts as well. And I'll touch on this. Okay, maybe let me mention now. For example, peer permissioning right now is a per node based peer permissioning. What that means is it mentions there that it uses smart contracts, but it's not there yet. There's actually a file that you specify e-nodes in, which is just a unique way of identifying different nodes. It's just a public key and an IP address. That is what an e-node is. And by using that, you can then specify nodes that are allowed to connect to your node. Okay, but it's a per node thing, i.e., if you have two nodes in the network, you can't control what that node. The second node might be allowing, nefarious people to connect. In the future, though, that
Why
will.
did you point to me? What's his name?
In the future, that might live on a smart contract, which once again means you have consensus and have a single version of the truth about who's allowed to connect to this network or not.
So what's...
Okay. Are you managing it?
Yeah.
Carry on. So quite a cool way of actually just using smart contracts to coordinate certain things.
It's the second time I've done that today.
Oh,
Do you want to just
Did you
switch
hit it
with me? Because I can't get this plug in.
Okay.
sorry?
If he goes.
No, I've also got plenty of power.
Here's a plug. You need
Is it plug? Is it plug?
power. There you go. Thank you.
Just suck juice.
That was easy.
We use the buddy system.
Wrong Robert.
Then what they've also done is they have developed graph-based consensus. So this isn't hot swappable. You need to. It's quite a intense setup process, and currently there's no dynamic membership. So you can shut once you've set up the graph-based network. You can shut nodes up and down, or turn them off and turn them on. But you can't have new joiners right now. There's already a pull request with the code in it. It just needs to be merged so that you can have dynamic graph membership. Okay.
Can you
yes.
then circumvent that thing where Theo's dodgy and he adds extra people?
In Raft, yes, exactly.
Because he set it
Yes,
up
exactly.
before.
Yes. Yes. Yeah. But with the dynamic membership, so it's sort of a different level of Obviously, you'd probably run these things inside a firewall anyways, so you'd have to be able to control, right? Or there are different levels of controlling your network. Okay, but this is more sort of on who's allowed to participate on a consensus level versus who are just allowed to be your peers.
Yes.
But currently in Raft, though, you won't even be able to join the network. Even if you're not voting or making new blocks or whatever, you won't be able to join. But with the dynamic membership, hopefully you'll be able to do all of that stuff. Okay. There's already a pull request for the code. It just needs to get merged at some point. Okay. So I've already talked about peer permissioning. And then on the consensus mechanisms, there's constantly there's an Istanbul Raft-based consensus mechanism that's currently being worked on. There's constant work to get BFT, that is currently being developed for different use cases. So, for example, if you don't have, so Raft pretty much uses the assumption that you have legal recourse to people in the network. So, absolute strong, you don't need it that much for the trust aspect of it. PBFT, you don't need that high level of trust. Obviously, the more trust you need, the more and closer you get to actually just using something like proof of work or proof of stake. Yeah. And then lastly, it just states that it offers high performance, and this is in part 99% because you can use a different consensus mechanism. But there's also certain other advancements you can do that you can't do in Get. For example, transactions have zero gas costs. That just allows, but there's actually this is more on the coding side, but there are a few other things that happen in Quorum that I'm talking about right now that they do to make it a little bit faster
and a little bit easier for devs to work with.
Yeah.
Zero gas.
Yeah, so zero gas, and I mean,
you need to specify gas is the price that is zero.
Yeah.
You all know how the gas calculation works. Let me quickly go. So in terms of how much ether that actually gets consumed for a transaction, it's gas amount, the gas limit, times price.
Yes.
The reason for the separation is the amount of gas consumed by a contract is sort of fixed. And you can optimize the code a little bit, but if you need 1,000 gas, you need 1,000 gas. Yeah. That doesn't help miners to decide which transactions to pick or which not to pick. So then you have the second parameter called the gas price that you can now set. And by adjusting that, you can make your transaction either more lucrative for a miner to pick or less lucrative if you want to save money. And you have to wait for blocks or whatever. Okay. Does that make sense? Cool. So in Quorum, they've just said you need the gas there because of the halting problem, but we've made it zero cost. Cool. So in terms of architecture, this is how Quorum setup all looks. I'm just going to zoom out one so we can fit everything on the screen. Is that big enough? Can you read that?
Yeah.
No. If it's zero gas price, how does it actually?
It doesn't consume it. No. So if you have a 1,000, then you'll have 1,000 afterwards. But you need that when the contract executes to sort of avoid the whole thing.
Gas is both like a deterministic computation insurer and also like an economic price incentive. It's very, very interesting how it works. There's quite a bit that you can find particularly on different sites about it.
And this ties into your question around dynamic strings. You need to be able to determine upfront everything about execution. How can you have some dynamic? And the same thing with dynamic sized arrays and all of that. So that's partially with some of the complicated concepts.
The other thing with gas, loops and sorting just kills it.
Yes, but that's what you sort of want because you don't want everyone to.
No, but I mean it's like if you've got something for some reason needs to be alphabetical order.
No, but you mean just think about it, right? Why don't you rather use insertion sort? So every time you do a transaction, you keep your list sorted.
Yeah.
Now you don't have the problem, right? Okay. So you need to just sometimes this forces us to think a little bit differently about how we address the problem.
Because now it's costing.
Yeah.
Sure.
And this is in the old days of
always cost. It's just it's becoming a little bit more obvious.
Yes.
Zillions of programs written out there, and people don't let's see the costs a little bit of that. Still costs.
Yeah, so program that one of the functions cost $50 to run. I'm not kidding.
Wow.
I was like,
So once again, the problem is not that the function costs $50 to run. The problem is the function is badly written. And people and developers have been getting away with it for years because you don't make it visible.
Yeah.
Or CPUs and
Yeah, the usual trend is that the speed of the machine will just make it
Yeah.
a null point, but it's not true.
So how do you prevent those situations in zero days?
you test.
So maybe I'm not understanding.
remember there's two levels to gas. It's the deterministic cost of running operations. So you have to supply the gas and you can always limit how much you're allowed to supply. So you can't create anything.
So for example, there's a maybe that is missing. So in a block, there's actually an upper limit about how much gas is allowed to be committed into that block. For example, there's an upper limit that you actually vote on that limit. The miners vote on it, so that it can move up and down. Unlike in Bitcoin, where it's fixed, you can only have a megabyte worth of transactions in there. Obviously, in Bitcoin, it's a little bit different in that Bitcoin doesn't. It executes a small script, but it's not a sorting algorithm.
You can't change the script.
You can't. Yeah, so. No, you can have different types of scripts that run in Bitcoin, but obviously there's no like variables you can set in there or something. So with with Ethereum, there's a limit to the block about how complex your whole block of transactions might be. So obviously, if you have quite a complex transaction, it might just consume all the space that is in the block, and that happens at the level where you actually construct the block and mine it. So in that way, because you didn't be able to determine how much gas this thing will consume, you can do it upfront before it actually gets into your block.
So even though the gas is not costing you anything, you also don't have infinite gas to use. So you've got a fixed amount of gas that you're allowed to use. And
If it exceeds that,
it just is not excuse. So
It can't be put into your block.
So what happens then is it just means if I start with 1,000, I was at 1,000, but I can't use more than the block that I'm on.
So this is an important point that this is a slightly more trusted network. If you technically adhere to the protocol, you could then construct like funky things to try and take the network down. But because there's legal recourse in most of these networks, etc., you're able to lower the boundaries and thereby achieve higher efficiency.
Yeah.
Okay. Sorry, I think that was probably the missing. Okay. Cool. So to get back onto how Quorum and what it does is, can you read that? Or are you looking at it on your phone? Okay. So it's big enough. So there's a bunch of steps here numbered 1 to I think 12, and this sucks. So it used to have the 12 steps just below it. Where is it now? It's not there. Okay. So they used to
I
actually.
think it's on the wiki,
Is it on the wiki?
but I'm not exactly sure
So
where.
we could go there and just see if it is there. No. Oops. Oh, yeah, perfect. This is what I was looking for. So if you go to this wiki, maybe you just paste this in Slack.
Where is this? It's the transaction processing.
Yeah, transaction processing. It actually has all the steps that are involved. It exactly addresses this earlier question around. Sorry, I'm looking at you. No, it's fine if you do other stuff. Exactly about how the transaction, then this split in state happens, and what actually gets shared publicly and what doesn't. So in a nutshell, I'm not going to go step by step through it because it would take too long, but go and read it. It's quite nicely set up. And so these numbers, like 12, ties to step number 12. 12. Okay. In a nutshell, what happens is if you do a private for or a constellation-based transaction, the payload gets encrypted, and a hash of that is shared on the public chain, but the encrypted payload is actually only sent to the specific parties involved in your private core transaction. But the encrypted payload is sent. Then that payload is encrypted with all of their public keys, so you can use your private key to decrypt it, and then you can actually apply that the data of that transaction to your EVM, and thereby run the code and update your private state. Okay, does that make sense?
So it's still broadcast the hash.
The hash, everyone has the hash. Okay. And what's nice about that is, say for example, there's a dispute about something, then you could actually sort of in some way prove that, but this is actually what the state is because I can get the hash out of it. And you can prove that process to everyone in the network that has that hash. Okay. Obviously, then you unfortunately need to make the private stuff public. So in some cases you just went
Of course, but a cool case would be
might be able. For example, you're able to keep the participants to whom you disclose is limited.
And that's just a public address. So whoever has the private is not tied to another meeting.
So by default, you set up your node with that key in it, but those keys are transportable to wherever you want. You will, for example, need to re-request all of the, because remember, it's just a hash that gets publicly shared, and the encrypted payload isn't sent everywhere. So you will need to re-request that private payload from the parties who you share it with.
So the encrypted part is just extra security.
It's extra security, extra security as well as blocks, right? So you add in lots of KYC information into these things. It's a brilliant way to segment the network that you don't need to have everyone to have all the data and all the storage space requirements.
What encryption does it
It specifies, PGP encryption. Sorry.
Oh, there we go.
Actually, PGP encryption is the recipient's public keys. And then the SHA-3 512 hash of the encrypted payload is. Okay, cool. But yeah, this goes into quite a lot more detail. And if you have other questions, so Pete and I actually met the guy that wrote this, Patrick from JP. Patrick's interesting. Patrick's a very interesting guy. And he comes from a cryptography world. So he knew the stuff long before it became sexy and popular. So he knows the stuff.
Isn't he like a Haskell key?
That as well. That's why this is written in Haskell. Okay, cool. So this is a little bit more on Quorum, the extra features it gives you, where to go and find out more about it. It's all open source on JP Morgan's Quorum website. Let's quickly move on to, and then third-party tools and libraries. We're going to use this Quorum Network Manager. Okay, there's a bunch of other things here as well. Another cool thing is, because of the close alignment between Quorum and Geth, of the two, you can actually just use the normal work-through JS that we've been using all the time for most things. And because, like, when you construct a transaction, all of the objects that just gets passed along, you can actually specify a private for in there, and it just gets passed along. Certain other things, like, for example, adding more block makers and block voters and stopping and starting and that kind of thing through normal Web3 JS doesn't work. So you'll need a Quorum 5 version of, and that's why you get, for example, a Java version of Web3J and the .NET version of like a version of the adapter. Okay, cool. Let's move on to the Quorum Network Manager.
Are you still actively developing on this?
I haven't had time for it, but I must make time for it. So Constellation has a new version out that I haven't been able to pull into this. It makes a few things better. So we're still using an older version of Constellation with the Quorum Network Manager. So if anyone else, so Andy's actually been great. He's contributed the setup script which we're going to use shortly. But any other contributions or things, please, fork it, get it do the change and issue a pull request and set up the pull rate. And maybe even get more people that can review code and pull requests. All of the stuff you can do yourself.
Yeah, this is
Just making it a little bit easier.
The fact that we have the use case, does nobody else have the use case?
No, so I mean, some people have obviously built these things to use for their internal network. We've just decided to open source it. Consensus is awesome like that. Sorry, I'm showing lots of. There's Cakeshop that you can use as well. It's not great, it falls over. Hopefully we'll be able to actually see Cakeshop in action, but I doubt it since we only have 45 minutes left. But Cakeshop is actually quite a nice UI that you can see how many nodes are going on. You can actually compile contracts and deploy them from Cakeshop as well, which is really cool. It's called the sandbox thing if you're looking forward to click on. But the tooling is slowly
So Ganesh is it's a new version of Truffle, which is UI, and I say how you can post that
it's not most stable right now, but it will be.
Why changing the name?
So it's quite funny. We asked the guys, I think yesterday,
Truffle will still do that. Ganesh is more
the UI.
Okay,
Yeah, like a second. So we asked the guys yesterday about Ganesh and its readiness, and one of the developers replied, "So it's a little bit more time to pay access."
Honestly,
Ganesh. They just say it.
people have too much free time sometimes. I mean, like, when Solidity first got going, there was a whole lot of stuff about like immortal and suicide contracts that just resulted in like endless fun.
They removed that though.
I'm so bleak about it, honestly.
Like we initially called it suicide, but we felt it wasn't sensitive to people.
Alright, so what you guys can do is you can go to this GitHub page, and you can just follow this. You can have a read through. So once you've SSH'd into your VMs, you can just follow this option 1, running the script instructions. Okay. Do this SED thing as well. There's a lot of like choose. I've submitted a pull request that have been merged into Web3.js. It just hides these logging of the true every time you add a peer, but unfortunately it's not in the most recently released version of Web3.js. So you'll still get a lot of these trues logged every time a peer joins you and stuff, which is just like spams your console output. So if you do this command there, this SED command, if you run that, it will just take it out. So you'll see here, actually, it just goes and updates the Web3 RPC node module. Okay.
The first time I ran that, it finished with a box that was saying something about pseudo privileges, and then it gave a recommendation to give access to the config file, and then I ran it again, and then the box didn't show up. But did it fail? Did anything fail when it showed the pseudo first time run or not?
I didn't see exactly the output, so I'm not sure. Okay, I'm not sure. The thing is, because we didn't have NVM set up with all the permissions of Node, Protein, and we're just going to kill these VMs afterwards, the pseudo things. Not everything, but any like npm-g install, just for now. Okay.
Are they not going to freak out if you run the same startup script multiple times?
Just create your own separate folder. What do you mean? No,
No,
you're all separate VMs.
You're all completely separate.
You guys
But you should be pairing actually.
Not
Not
logging independently.
yeah, you should be sharing.
That's
You're not
the last box.
But then that bottom line where I read that.
You guys,
And then I read
why
it
don't you just take an extra VM there?
No, it's
I think what there is
One, two hardcore developers down there inside.
Might be, I would not. I didn't know. Yeah, I would not maybe have run the setup script the second time, but it should be alright.
all it did was do a lot of extracts and then the APM was all it was
Oh, did it actually exit after? Oh wait, just show me again. Sorry. Sorry, I missed this.
and And then the second time.
We'll find out now. Okay. So don't pseudo run the setup script, okay? Because it's great. It creates directories and things for you, and then it's gonna have the wrong permissions.
One moment.
Guys, there are still some VMs. If you don't want to share, there are still VMs 9 and 10 left. If someone wants their own VM.
And Theo, let's see what Cake Shop looks like. Please don't turn off my lights. But you'll see how insecure but cool it is. Sorry, Cian, yeah. The Quorum Network Manager, and I'll put that there.
If you use that address with Cake Shop running, I can message that on the name of my channel.
I've put it.
No, it's still running on my duplicate. So it creates the folder.
Okay, is everyone running their setup?
Yeah.
Yeah.
There's still VM 9 available.
It's pretty neat, right? So it's quite nice to be able to show to like business people and execs.
Sorry, I don't think
This is what a blockchain looks like. Like it's, you can do lots of things from there. It's already turned off my node. Done lots of things. I think that you can, yeah. And certainly, like, you don't get the sources. I've just wrote this in a .war file. So I haven't dived too deep into the actual source, apart from playing with like the application file.
Sorry?
Yes.
Yeah.
Carl, do you know what the password is, or do I need to mute this?
So I think 1 and 2, I've already run these setup scripts.
The nice thing about this, I don't need to use any of the full resources you want to use
Go for it.
Please do it. Not put the command lines with the numbering so that you can just select them all and let them run.
Please do go. Get yourself in as a contributor for removing some numbers. Woo! So in fact, on that, one of the coolest things, the commit ETH guys are very, very close to being done with their next version. And it's going to support a sort of a variety of tokens, because there's some other token standards out there. I don't know if you guys know, apart from ERC20, there's Mini-Me and ERC223. Which just have some slightly different functionalities. Mini-Me in particular is very cool. I mean, you know what committee is, right? Yeah. So I'm a big fan of that for open source contributors. And I'm really hoping that when we have committees going properly, Kunya will start contributing to the status repos. So.
I think status is such an important part of the ecosystem. I'd actually like to be more involved.
Yeah.
I just wish I had more time.
Don't we all?
Well, yeah. I think I'm busy. I've seen me busy. Am I busy?
Slightly different. Well, I mean,
it's just a pity those 18 hours spent in a tin box between places doesn't leave you able to contribute well.
Well, I mean, these days it's all Wi-Fi'd up. Hey,
It depends where you're flying. If you're flying over India, then
oh, really?
Yes. So between Dubai and Singapore. So you have internet like right at the start, and then you're over India, and then like right at the
run a script.
So they need to just get some balloons float over India so that your coverage stays on.
We should do that. We should do that. But right now it's not.
I mean, you have it the whole way through Africa, right? Like flying over Africa.
Yeah, exactly. That's what I thought. No.
But it might be the angle of the satellite talking to the plane. Maybe there's no coverage.
So I've had it both there and back. Multiple times in Beats as well, but there's just no
So, because I mean, I was blown away like by flying. I mean, we flew up to like Europe, right? And it goes into the whole way. And I wonder if it was just Turkish Airlines or.
Yes. So this is specifically with Emirates. Maybe there's just not the Emirates and India agreement is just not there.
Yeah, don't
But
have
maybe
a-
for a different carrier. I don't know. Okay.
Cool. So does everybody have that script right?
So everyone is
running.
Is it still running? Okay.
Does it can take a little while.
You install
I think
a long time.
now that everyone's sucking off the internet at the same time.
Yeah. So maybe
It's not
then,
our internet though, right? This is Azure. Thanks,
this is
Azure.
Azure, so it's their internet.
Yeah.
So maybe
There's,
while
there's
that's
a lot of
busy
stuff
running,
to install.
Yeah.
It's,
So while that's running, let's go through. I'm just going to talk through these manual steps, just so that you get a gist for everything that's busy getting set up on your PC, okay, or on the VM. At least. I think that's another reason why we do these on VMs and not on your personal machine. So you don't know what like stuff I've done in there, sending your MetaMask.
well, one of, and also the fact that we need a bit 16 to run Constellation, right?
That's also true.
Yeah.
Yeah, like Windows don't even try.
Yeah.
Um,
I mean, just in general, but also with Quorum.
I don't say it, but I
Mac
agree with it.
Mac, Constellation. Try, don't try.
I think you can try to compile from source. So Patrick has added lots of documentation about how to try it because he uses a MacBook. So yeah. Okay, cool. Let's quickly, while your setup scripts are busy running, go through everything that's getting installed. So first off, it installs Go. So not 1.8 right now because Go Ethereum uses 1.7. It assumes you're working on Ubuntu 16. Well, you can use newer versions of Ubuntu, but that's the VM we've set up. It will also install a Node, the latest version of Node. Okay, then it does these. It installs Ethereum, and that's just because I've been too lazy to figure out exactly the packages you need for things like root nodes, which we don't use, but some other things we do use. There's some specific packages that I just haven't been figured out exactly what they are, and this installs all of them for you. Okay. So maybe just on that note, the Quorum Network Manager is meant to like help proof of concepts and not necessarily run networks in production. Okay, just keep that in mind as well. It's a little bit of a disclaimer.
This is not
Yeah, I'm not a lawyer.
Okay, cool. Then what the script does is it moves your get binary and it just renames it to a normal get because we want get to point to Quorum and not to get if you type it in the command line. Then we install Quorum, and to build it you need Build Essential, and we add that version of the get binary that's in that build bin to your bash RC, and then you source it to get it in your path. Then we install Constellation, so a bunch of things for Constellation. You get the binaries, chmod so you can run them. We add those binaries to your bash RC and source it. Then, in order to generate a Genesis block, there's quite a few like syntactical things you need to remember. So someone just went and wrote a utility for that called Quorum Genesis. It makes it easier to generate a Genesis block for you. So it's quite cool. To this thing, you just specify like the specific parties and addresses that you want, what consensus mechanisms you're using, whatever, and it generates it for you, the Genesis block. At least the Genesis block setup. Okay. And then this step then just installs the actual Quorum Network Manager, the repo that we're looking at right now. And then this set just removes those logging of the trees that get logged when you have this. Okay, that's all essentially actually what the script does. Obviously, there's tons of other packages and things you can use. So, okay, where are we on the script installs? Okay, let's continue.
Snaps for Azure.
Azure is cool. Okay, then maybe while we're busy with this, just finish off about what's on here. There's a couple of other things you can do. So I talked briefly about account management, what Constellation does, how you can pause block making if you need that. There's good reasons for not to do it, but there's good reasons for also doing it. So I just give a little bit of a description on that. I then specify the firewall rules that we'll be using. Obviously, we won't be using this because we're not using Raft. In this specific case, we're not using Raft. And then this is for Cake Shop. So hopefully we might get around to this, actually setting up Cake Shop. And then yeah, some more Cake Shop stuff. And that's pretty much it. I go on to a little bit about I started on analyzing performance gains you get from Quorum, but this section actually needs to be deleted. Okay, cool. That's it for the GitHub page. Let's go to. Oops. Let's go to this. So what you need to do is you'll need to be in workspace in the Quorum. Sorry, so if you do Alice here in your workspace, you'll see the different projects that I just talked about, right? Constellation, Quorum, Quorum Genesis, Quorum Network Manager, and the setup script that you've all just run.
Yeah. Sorry, just above workspace, mine also created a Quorum Network Manager in my network.
Just say again?
You got up one folder. I also got a Quorum Network space in here.
In here?
Yeah.
That's strange.
Must be in the wrong folder.
Yeah, that's strange. Just have a look. What is inside your workspace?
Constellation Quorum Genesis.
It should be alright. Just to double check. This shouldn't be an issue. Just make sure that this is pointing to the correct get binary. Okay. This shouldn't be an issue, but because you had your path issues, is it in the correct place inside this Quorum folder?
Just pull it to make it the same issue.
Oh, interesting. Okay, sorry? Okay.
Ghost in the machine, man.
Yeah.
So
Yeah, cool.
You get no response.
I get no response.
Oh, wait, you
You
got.
gotta do a which gear, it just says nothing.
No. Okay, then you need to do it. Actually, no, you can't do. So just log out and log in again. You can't do a source for this. It's that issue. Yeah. Okay, cool. Then what we do is we run node index
From inside the network manager.
Yeah. It uses a quite. So previously you needed to type in your IP address, your internet facing IP address. It now just goes and gets it for you. Obviously, if you're running it inside this, say for example, we wanted to network these machines, then you actually go and change the IP address.
Yeah.
Okay. Enter. We're going to use Quorum chain consensus. Actually, because I've run this before, you need to just hit 5. Just make sure everything is dead before we start. Okay.
Wait,
You didn't need to hit 5.
Yeah,
Just the two of us because I tested this yesterday.
so
Okay.
I'm getting the prompt for
Yeah.
Ince address.
Yeah. It picks up your IP.
Okay. Pick option 2. Okay. I'm actually just going to do this. We should have actually run this in the screen. So before we start, just do a sudo apt-get install screen if it's not already installed, and then do
Screen capital S, and then give it a name.
like Quorum or something.
Yeah.
Do I need to paste any of this in Slack, or you guys all following? You got it, okay? Cool. Just option 0 to exit. We're gonna just do that now again. So once you're in the screen,
We might be buzzing out.
yeah. Carl, please tell me if I need to.
Screen
I'll show you now.
It's a really neat way to manage like a lot of different windows in one. So
And leave stuff running after you've exited.
so yeah, if you just screen dash capital S Quorum,
Yeah.
and you'll
Just run that. Okay.
Then just run the node index.js again.
When Kenny first introduced me to the screen, I was equally confused. But it's really like it's super easy for managing processes.
Different tabs.
Yeah, exactly.
Yeah, exactly right. Yeah. Just a different tabs that you can flick to, and then the other benefit is you can leave stuff running after you've exited your server quite nicely, quite easily.
Screen might have some issues in Python.
I don't know. It should run on the server.
Screen is on the server side.
Yeah.
Might appear the screen.
But I'm just saying, like, in terms of the hotkeys,
It just clears the screen, like yeah. Like if I okay, cool. Anyway, it's so public IP address, quorum chain, consensus. So I'm gonna select option 1 since I'm gonna just coordinate us connecting. Okay. You guys need to choose option 2. Okay. And then I'm now just gonna say we're only gonna have like one block voter, one block maker. So maybe I'm aware of the time and standing still on things, but this is just to do with the consensus mechanism, the quorum chain consensus. Just some parameters that you're setting up. Okay, I'm going to say minimum time between blocks 1, maximum time between blocks 2, and as soon as there's one vote, it's going to accept the block as being valid. Okay, then I'm going to generate an address to use from which to sign transactions to make blocks, as well as vote blocks. So I said here select which. So I could have copy pasted addresses in here as well.
Okay. Yeah. Unfortunately, we are sort of moving a bit quicker. It is worth noting just very quickly that like those minimum and maximum block times, like that is a really major advancement. So like we did some testing here with running like a proxy voting solution on normal Geth. And we were sort of able to get like a 5 seconds wait time to confirm a vote at first when we were just running it on 3 or 4 machines. But literally within 2 weeks, we were waiting 45 seconds because the difficulty had absolutely skyrocketed. Running like 3 or 4 machines, you can never get through it. So like it just takes ages and ages and ages to mine a block. And if you want to change that, it's fine. You can go into the Go source code and like take out that specific line and then recompile it yourself, but it means that then from then on you're having to maintain your own code base, and you don't want to be doing that, especially when Ethereum's moving so fast. So like that, just that in itself, like, is a huge thing, right? And when we talk about performance and management,
like huge reason to use Quorum for any like private type of network. Yeah. Cool. So now my network's up and running. For you guys to join, okay, so
in the Slack.
So waiting for IP address, just pick the IP address that's next to Quorum 1 as the IP address to connect to. So what will actually happen now is and then join as a participant. So option 3, join the network as a participant. So what is happening now is it's first of all actually joining 2 nodes that only have Whisper on them. So actually it's joining all of your nodes to my node that's running Whisper. Okay? And in doing that, it can then ask my node for certain setup things, like what is the Genesis block? And then it actually transfers the whole Genesis block to all of you guys.
Via Whisper.
Via Whisper.
It's really cool. Really cool.
Which is the manual thing that we want to share the very first time.
Exactly right. Remember the NetBank in that room where we used to shock every time we tried to touch the door because they had the grass as a floor. Yeah. So this transfers the Genesis block to everyone. Okay. You didn't run set that. That's fine. So that's every peer.
There is a little line in the Quorum Network Manager page that you can run.
Okay, cool.
Stop that. Yeah, so there's
so you didn't run the set command as well.
It says optionally, so I wanted to see the ones.
I did say you all get spammed. Okay, cool. Once you've joined as a participant, so option 3.
Requesting Genesis block.
Not super long, but
So,
it checks like
I mean,
only
you
like
guys-
once a
you've
minute or
joined,
something.
right?
So,
So don't worry about any more options. Like you have.
what
you
what
received
what
the
we
network
what you
config,
can do then in screen is you
the
can hit
network is
Control
not
A D to
running. So
disconnect.
that's
I'll come
how
and
we
help
run
everyone
it,
individually
or
now
like
to start. So
when
don't
running
stress about doing
screens,
stuff.
then now you
I just want to get to a point where you can actually see the peers that are connected. Okay. So control, you keep control down A, and then you leave A, and then you press D. And then it detaches.
Do we actually have point the network manager?
You can, but ideally don't. Just leave it in screen running there. Okay.
Yeah, exactly. So like Vinny says, you know, it's not ready intended for production.
You can use other scripts to just reconnect to it.
Because
Because remember the Genesis block is transferred now and saved.
So like
There's a node running in the background.
Yeah. But what the network manager does do is everything with Whisper.
Absolutely.
So if your network manager dies, then some of the Whisper stuff just won't work.
Okay, can I run the network manager?
Yeah.
No, you'll need to rejoin. You'll need to actually quit
all
and
these little
just
dots
redo a
setting
reset.
up the Quorum network.
Do you want to test that? Can we just test some other things before we do go on to that?
More
Okay.
that my network fabric manager actually allows.
Oh, then just rejoin. It's fine. Just pick option 2.
Because we've got
with
like
my
a
IP
full
address.
10 machine network now.
Just do everything again.
5 minutes, right? And if we weren't
Okay,
stopping
cool.
to
Guys, let's move on.
yeah.
So to exit or stay attached to detach from screen, Control AD. Okay. Once you're in
Control
the,
AD. Yeah. Cool.
once you're in the detached
And then
state,
to see your screen dash ls.
yeah.
And
So
if
you can
wanted
do
to-
a
dash ls.
you can do a screen ls to just see the other screens that are busy running.
Yeah. And then if you wanted to reconnect screen dash little r.
Sorry that I'm not
And then-
diving
and
into
then
the
the
screen
name.
utility, but I thought
Okay.
do blockchain stuff. Okay, so now to actually connect to a node and do things on your node, it's / attached to local quorum node. Okay, and you can use tab complete. So / att tab to tab complete. Enter. So this
We're not
brings,
running this in a screen. Right?
no, you don't need to. This you can come and go as you want. You can exit and enter this as you want. So if get is not found, just log out and in again. Unfortunately, you can't. Yeah, yeah. It's about if you do source your bash RC, it's sort of in a child instance. It doesn't bubble up to your parent where you're actually running the script from. So you can't actually fix that. You need to unfortunately relog. Okay. So once you're attached to your get console, this is actually super cool. This is a fully functional JavaScript environment. So anything you can do in JavaScript theoretically, you can do here. So like if you have an array, you can do a .length. You can write loops. You can, as an example, that pause block making script earlier is actually just a JavaScript script that I load up and run. And then it executes because you're in JavaScript, which is quite cool. So now what you can do is you can do an admin.ps and to show you your list of peers. Okay? And just to see, and now because you get an array there, you can do a .length. And we currently have 8, so 9 nodes running. Which should be sort of correct, I think.
Yes.
Okay. Sorry?
Unless you get the same amount.
Yes?
Yeah.
Actually, no, we're not. So the reason why you not necessarily have the same amount is these networks, connections come and go all the time. As long as you stay connected to at least like 1 or 2 nodes, you should be fine. Yeah. In the public network, I can't stress enough how important it is to make sure your network topology is set up that you are connected to peers that are independent of each other. If you connect to a bunch of peers that is the same entity, they can spoof, they can submit incorrect information to you. Because this is your entire view of the network. If your peers withhold any data to you, you won't know about it. And this is why in Bitcoin or in public Ethereum, it's so important to have a geographically diverse set of peers. In order to make almost sure that you aren't connecting to the same entity that can withhold data from you. That's how Craig Wright tried to convince Gavin that he is Satoshi Nakamoto. So yeah, okay.
But really, we know who the real one is. I'm just messing around.
So you can actually see, you can see your peers, and you know, I was talking earlier about that. And then you should be seeing that some of these will be on. There we now have 9, so 10 nodes, 10 node network. Great. And if you do just look at peers, you'll see some of them are on different heads. Some of them will be on the same heads in terms of blocks. And that's just as the blocks are being propagated. Okay, and you can see the IP addresses there. You can see actually quite a bit of information just from looking at your admin of peers. Okay, but this is not really interesting stuff. Let's actually transfer. Maybe we'll just get around to transferring ether, unfortunately. Yeah. But the important part is this is sort of the networking part. You know, this you sort of set up and you like leave an engineer in charge of it and he runs with it. Everything else you build on top of this. And this is why we started with just using test RPC. So that all of the stuff is sort of done for you, and now you can build it up on top of it. So it's important to view the whole stack almost, right? Stuff that gets built on top, and then the stuff that actually runs it. Okay. So now let's actually, so if I do, so to view accounts, you can do f.accounts, but you'll have none. I'll have 2 because remember I created the 2 accounts to sign blocks, making of blocks and sign the voting of blocks. What you can do is you can do a personal.new account. You just hit enter, and then you have a new account.
Well, it'll ask you for a password unless you pass one.
Yeah. So you can if you do personal.new account, you can do just an empty password for now. It doesn't really matter. So remember, even this password is used to encrypt and decrypt your private key that's kept on your node. So even if you know what my password is, you won't be able to spend my funds because you don't have my private key. It's only once you've hacked into my hard drive and stolen my encrypted private keys that you need my password to decrypt. Okay, yeah, just on the side. So once you have an account,
This is the world.
Sorry?
This is why I'm broadcasting this to the world. My password in plain view.
So once you have that and you do s.accounts, you'll likely see an account. Okay, so does everyone have an account at least? Yeah. Okay, now, so this is unfortunate, but hopefully this works. You should all have received some ether.
That's how it works.
Right, so s.getBalance. And now because this is JavaScript again, you can actually just use s.accounts with 2 C's.
Yeah, see that's but that's given in way, so if you
in way, yes. Yeah. So s.accounts, and then you need to index which account you're busy. So you guys will probably have 0 in there. In way. That's the amount of ether, but in way. So I think it's about 1 ether. I can't actually remember.
It is 1 ether.
I think it's 1 ether.
So I think
yeah,
from way,
you can
right?
Yeah, exactly that.
It is Web3, not ETH.
Yeah.
Web3 from way in camel.
And then you need to specify, I think, what you want it to.
Is it on the outside of the
Oh, you don't need to. Okay, so earlier you needed to specify ether.
Sorry?
From way by default goes.
Yeah, it does.
Okay.
Give it an optional.
You can do it the other ones.
Okay, if you do it the other way around, then you need to specify ether or whatever. Whatever.
Sinise, Zabos.
Yeah, all of those you can.
Yeah.
There's like a whole, quite extensive list of different.
And that ETH is also being sent by, the account creation was gossiped by Whisper, right?
Yes. So this is also another thing that the Community Manager does for you is when you create a new account, your node tells the rest of your peers that, oh, I have a new account, but I don't have any ether. Please send me some. And then if there are any nodes listening that want to send, currently there's only one node listening that will send you ether, my node, that will send you some ether. But 1 ether is enough because, like we said earlier, you're actually not consuming this ether to execute the contract. So.
Can we quickly maybe do a truffle and box? Because it should give you the migration and maybe
Do you
even
want
better.
to? Okay. Do you want to quickly do it?
And then at least we'll be able to show changing the RPC to 20,000. Now you guys can
We can do that.
What did you want
We
to
can do that.
first?
Well, I thought it might be useful to actually just transfer some ether around and actually show public versus private.
Okay, let's do that rather. Because that's
So let's quickly. So we have a couple of choices. We can now show you how to connect to this network from your Truffle DApp that you've. So you can adopt pets on a single network, but that should be pretty easy. You can just Google for how to add a new network to Truffle. Let's rather actually do a public and a private transaction.
Yeah.
Okay.
Adding a new network to Truffle is literally just copy that network objects, and call it Quorum instead of developments, and change the RPC port to 20,000. That's
It should be.
the sum total of the thing.
Yeah, they have a Quorum Truffle as well.
They do, exactly.
Sim.
I was more interested in what you need if you were using that other switcher we were talking about.
The Infura.
Infura, yeah. Like again, if you sign up for Infura, you'll see like it's very, very obvious which endpoints they give you, and you just like
Give you like an HTTPS.
yes,
You just put that in there.
yes, rather than localhost. Yeah.
What the background?
It's like weird stuff that was going on.
Oh, I don't know what the background is looking like.
It
That.
seems like someone drew on.
Oh, I think
There.
that's the.
Oh goodness.
No,
It's
a reflection.
from outside. That was so weird.
Being like, whoa, what have they put in the water? It is.
Can I have a copy of your UI?
No.
Like that.
Now you guys,
Background.
now you guys know why we're so productive.
Squirrel.
I just want to get quickly that load script. So if you have that, so if you can deploy the private contract. So I need this. And where's that solved? Oh, here it is. Okay, sorry. Okay, that's fine.
That's okay.
Oh, it's okay. It's okay. Okay, so what I've done now is I've just created a little script. It has some Solidity source code in that we'll compile. Using this command, it then gets the correct parts of the contract and it then deploys it. Oops.
Which script is that?
Okay, so let me quickly paste it on Slack.
It's a sense that using
Yeah, exactly right. This comes from the Quorum example. Okay? So I will need your private fours. So another thing you can do with Whisper is actually just communicate these private fours. So this is the public address of your constellation node. Obviously, I don't have any of yours. So maybe if I can just get that from one of you guys. I'll quickly show you where to get it. Just paste it on Slack. I'll probably only do a private 4 from one of you. Okay. I think it's in Constellation. Node. Oh, so you can just cat your Constellation node to pub. That's it. Public key. Just paste one of those for me.
Where is this thing? Is it in the constellation group?
Constellation isn't always that.
No, go up.
Because there's nothing.
Up. Oh no, so inside the Quorum network manager.
Oh,
Yeah.
Okay. Well, which file do you cat?
Constellation.
Yeah.
No.
So inside the Quorum
No,
network
no,
manager,
but-
there's a Constellation folder. No, the key is the private key.
No,
You don't want
no,
that.
that's
You don't want to share that.
Ever.
I'm just gonna pick one, okay? Sorry for. So it seems like body was the fastest there.
Not saying anything else. So
Friendly guys at R&D, eh?
I heard
we'll
about
hang it out
this.
afterwards. We'll hang it out afterwards.
About the.
Just confirm you should have equal sign be in front.
Yeah.
Okay.
Okay, and then we can just attach again, and then we can
Broken up.
load script. Script one. Oops. .js. Oh no. Okay. Sorry, I just need to install Solidity as well. I forget these are brand new machines, right?
So I'll see.
So I'm just quickly. So what happened there was I couldn't compile the Solidity source code to deploy. So I just needed to do an npm. There's an npm install, but there's a sort of update install as well. So once again, I attach. I do a load script. Cool. So there, it mined the contract at that address. Okay. So now what you can do, let me quickly just share this address for you guys. So if you guys actually look at the at your blockchain, you can actually go and see that this transaction hash. Let me just paste that as well for you guys. You can actually go and find this transaction hash in the blockchain as well. If you guys are, you can do. I think it's eth.getTransaction and then just specify the hash. Let's actually quickly maybe do that. Oops, not there. So there's the transaction that deployed the contract.
Did you put that in the Slack?
Yeah.
Is it in the Slack?
It's in the Slack, yes. Okay. And you can see the block number there. We're already at 1,144. Gas that was used for it. Gas price is 0. The input to it. The nonce. So this is the 6th transaction that this account has done. And some other variables. Okay. And so this.
Private 4? Is this a private 4?
Yes. So if you open up that script, you'll see there's a private 4 in there.
But you can't see it in here.
No, you can actually. And that's it. So if you look at this this version bit, so this version bit 25 is, there's another one, I think 26 or 24 is also private, private. So normal non-private one will have a different version bit. Okay, cool. So then if you go to Quorum examples. So let's create a variable with that address that I've just given you guys. Yeah, I do that Control Shift. So address is equal to, and then let's just get that address from Slack. Contact address. Okay. Then if we go back to, now we need to just create a variable for the ABI. So this is just so that we know how to interact with it. So you guys can follow along. But obviously, since I did it in the private before, you will probably not be able to see anything, but we'll show you on Bardi's computers that you can see it.
I'm gonna,
So you're going to do your own one?
Yeah,
someone
with,
else's. Right. So you
whose
guys can
was it?
actually
I think
do
it was yours.
whoever's constellation key you want
Cool.
to. Great. So I've made a variable for the ABI. So that's all of this is on this one, right? You can just go to the Quorum examples, 7 nodes example. Okay. They have instructions there about the var address and all of that. And then let's just do this. So what this will do is it will, because you can have multiple contracts that have the same ABI deployed at different addresses, let's just make sure you're talking to the correct one. Okay. You just copy that.
How did you find the
It was when you deployed it, it said it.
Oh, really?
Yeah.
Oh, is this it? Yeah.
It should be somewhere there. Actually, you had an error there.
Oh.
Yeah.
Uh,
Yeah, you had an error. It's
Huh.
probably to do with your account being locked. Okay, so another thing is if you guys have, so my accounts were already unlocked. If you guys created a new account into which you would have received that 1 Ether, you need to do a personal.unlock and then specify that account.
Yeah.
Okay, jeez, someone's spamming.
Someone's phone's ringing.
Someone's phone is actually ringing.
uh,
Were you able to unlock your account and it's still working?
yeah,
Okay, I'll look at it just now. Okay.
no problem.
Okay. Just make sure that the constellation key is correct.
Yeah.
So if the constellation key is not correct, it doesn't know with whom to share the payload, so then you can't actually issue the transaction. Okay.
Sorry, I'm
Ah, Louis,
Sorry.
killing me.
Yeah, so it needs to know the exact private key because so what it does is it keeps a hash map of your private key to IP address from which it needs to then send the constellation stuff out. Okay, all right, cool. So we've done that. Now we'll be able to do this private.get and set. So we can see that it's 42, and we should also be able to write. If we now do a set, set it to 1,
Aha.
there's the transaction hash, do a get. Ooh. Why is that not working? I wonder.
Awesome. Louis, we're in business.
Wait, sorry. Obviously,
I'll drop the transaction hash.
Obviously, this is a private transaction, right? So I need to specify the private for, first of all. Secondly, I need to specify from which account to send this transaction because since I need to sign it with someone other privately, right? So I just need to actually create this. Sorry about that. Okay, so we're going to set it to 4, and you can just quickly get bodies.
So this is that example where it's set for when you actually do the transaction as well as specify the price.
So if you do a private.gets,
You can make a private for contract shared between the four of us.
So, yeah,
But then do the private
Private for transactions.
there we go. So now if bodies is a get, you should also set your data. So now let's quickly deploy, I know we're out of time, but let's quickly deploy a contract without a private for. And then everyone will be able to see it. And then everyone will be able to set that value as well. And we'll have consensus on it. So, not chaos. So when we did this exercise at the MAS, everyone was like just throwing random values in there. It got quite chaotic. Like every time you did it, I would get different. So any of you could actually now theoretically deploy a new one. Let's actually just. I actually want to exit this.
Save the script that you do your like.
so like you save it in this in Quorum network manager,
Quorum.
yeah, and then like or anywhere, and then give it a reddit path.
Yeah, but aside from where you did the attach.
Yes. Yeah, exactly. So it's just easiest to have it there.
Cool. So I'm just gonna remove. Oops. Come on.
Yes. The R should just
Just gonna remove this private for section.
yeah, because it's a check. That's very interesting.
There's a couple of
And then I'm just gonna say, I'm just gonna make this default value to say 10 just to match something different, right?
Yeah.
Save it,
but
just deploy it.
you do that with balances. So
What is this? Come on. Oh, it's not in the No, what's happening now? Did your internet die?
It's totally possible. There's on that there's Kenny's Quorum Nostro demo is pretty neat on the sort of private for the balances and that kind of stuff. There's a GitHub repo
There's people worked on it as well.
that we can point you to. It's, that has like it's a pretty neat example, I think, of like using private fours in a very, very simple Nostro setup.
Yes, I'm just trying to get my head around the state.
So I've just pasted a
Join the
new
club.
new public contract address. So just run this line again, var address equals, and then you need to rerun the this one as well, var private, because now it's a new address, right? But the API stays the same. Now if we do private.get, did I not? Oh, sorry, yes, I just did a, sorry, yes. This is what pair programming is good, right? Okay.
No integrated terminals, no peer programming.
There you go.
All the tests.
I don't like it.
Yes.
So now we should be able to do private.set. There should be no private for. Oh, that's interesting. Why is that not working? Can we just quickly?
I think that while Kenny's getting this up and going, like the point here is that like these 7-node examples and even the permissions example provided by Quorum are really, really great to go and like play around with, and like give yourself a sense of like what's possible with these things. But as Pete says, you know, it's not likely that you're going to be using like privates for when you're just getting and setting values. It's very unlikely that we ever have that kind of use case. But like I'm a particularly big fan of the idea that sort of clunky KYC and AML metadata that goes along with transactions that doesn't have to be shared and stored with the whole network gets put in the private for, and whatever is sort of like key to the transactional information that does need to be transparent and open is sort of stored you know, in the normal transactional details. And even more on that, you know, if you think about like the longer term vision of you know, keeping the sort of permissioned and public networks kind of in lockstep, you can definitely imagine a world in which like the transactional information is kind of settled on a public chain, right? And yet you've still got the ability to do KYC and sensitive metadata and all the sort of PIID stuff in your private fours, and sort of keep that segmented from like the big bad public, right? Because you don't obviously want that sort of stuff having any chance of leaking out. See you.
So you're
Lovely
cool. Sorry, we didn't get as far as we wanted to. But I think it was maybe a little bit ambitious to start with.
That's really the secret sauce that probably makes this usable in our space.
Yeah.
Everything just being everywhere.
It doesn't quite work, right? Like for all the great rhetoric around public, transparent, open, permissionless access and whatever, like you know that if you spend any time in financial services or in any industry that deals with like personally identifying information that can be tracked back to you, and like there's a lawsuit that's coming at your company for it, like we know that doesn't work, right? So this is interesting stuff. It really is.
And then, so what we actually do at the MAS, for example, is we set up the transaction using Constellation, and then once you're ready to actually do the transaction, then you actually use zero-knowledge proofs to then have public consensus on a value transfer without revealing then the amount of the balance. You do reveal the sender and the receiver, but because you only have a limited set of participants, it doesn't. I mean, these guys are always transacting with each other.
Yeah, that's not interesting information at all.
You can do several zero-value transactions as well if you're really that inclined to.
Yeah, but yes, it's not big news to anyone that JP Morgan's transacting with Credit Suisse or that's standards with FNB. Like that's run-of-the-mill stuff. It's the balance.
It's the balances and then the amount that JP Morgan is sending to that you want to
answer. That's really nice. Yeah.
So that's quite cool. It would have actually been cool to show you guys how we generate the zero-knowledge proof as well.
Is that a
and it's a bit involved. Obviously, once you've set it up, you can just redo it. But there's a little bit of involvement.
So, I mean, we can always do another one of these days.
So
Right?
you
Like
don't-
4 hours out of everybody's day is not a big ask. And if we focus specifically on maybe a little bit more of the private 4 stuff in Quorum and zero knowledge, I think that would be very beneficial for everyone. So,
They have
That's and
from some other
to get a better traction on the cash use case. So if we could have a bit of a view of what we actually want to build and instead of
yes.
start funneling it and
Yeah, so I think the Nostro demo is a good place to start for
It's not the
that.
same guys.
And then
Not exactly the same guys.
I
but
agree.
it's the
Like
same
we just
library.
need a specific payments use case. I know that we already built one, right? Didn't we do one for the SAB where FNB
Probably
and
not
standard
that
were
library,
transacting?
but
we did that right in the beginning, but it was just
With
so
vanilla
you can still view that because it takes several seconds
but yeah, that's that was our first.
Maybe Fuzz, we need to speak to him a little bit.
Yeah,
I think he'll get some direction there. But like this is definitely what we want to be using to achieve it, right?
So I mean, you can go look at the Zcash. So the Zcash network is using this. In the public space. So Zcash allows for 2 different types of transactions for public, like Bitcoin style transactions, as well as shielded transactions. And in the public transaction, it's like Bitcoin, you can see everything. But then if you use the shielded transaction, you can't see from, you can't see to, you can't see the amount, you can see nothing. Just question mark amount to question mark. Like in their block expression. It's quite helpful.
You just know a transaction occurred.
Sorry?
Yeah,
come down.
Nothing about it.
Yeah,
It makes it very interesting. I don't know who posted it. I think it was Gary on the Slack channel where people voted which one is the most secure way to
That is very
transfer the
funny.
other one thing on.
Yes. Like, yeah, Zcash was like just above other.
Yeah.
so
It was actually John. He's a very clever guy from UCT. He's busy doing his honors on using zero knowledge proofs for voting.
yeah, him and Jason, those guys are gonna go far. Jason actually, I'd sort of led him through the status hackathon. They won like $1,000. So those guys are doing good work down there. Could perhaps like we can like set a tentative date, or at least put the idea out that we do like another one of these sort of 4 hours. You don't necessarily like have to do it in person, but like maybe it would be nice to do like maybe the next time you have a joke, we do another 4 hours on like a little bit more on the private 4 and maybe a bit more on the Nostro demo and zero knowledge. Because like Jan says, we sort of let's have a look at this cash and payments use case, and in order to do that, we need a specific example we can go after, and maybe like the Nostro demo is the place to start for that. And in 4 hours, you should be able to get through that and setting up your zero knowledge. So maybe
We won't be able to. So currently, you can't tie the zero knowledge to the network because we don't have the pre-compiled in the network available. So you need to verify and prove, generate the proof and verify, but off-chain. And if you do it off-chain, then you can. There's not some ways you can work with it. But in the future, we'll have the pre-compiles to verify a proof on-chain, and then you can create